And we're live with a Midwinter Nights Con 2020, wrapping up this insane year with something that I think will bring joy to everyone. So I'm Ken Johnson at CK Tricky, joined by a ton of co-hosts, but I'm going to point out at Seth Law at Seth Law on Twitter. Seth, say hi first.
Hey, everybody. Welcome back to another conference, right? It's not another episode at this point. We're going to run for a couple of days. We're really excited. We've got a whole bunch of co-organizers and co-hosts that are helping us out with this one. You may recognize some of them. You may want to stone some of them. I don't know, right? Just get Google ready because there's going to be a lot of good stuff coming over the next couple of days, right? I mean, anytime we have Stefan speak, we know that there's going to be, at least, an uptick in those Google searches, if not a little bit more. Yeah, Ken, from a pure just organization perspective, what else do we got? What else do we need to cover before we jump into it with the first talk?
Right. So just a few things. We did put two charities you can donate to. They're on the agenda link, their agenda page here, which I'll post into chat now. And again, that's the agenda page that we just put into chat. In our Absolute AppSec Slack, there is a Midwinter Nights Con channel. So if you're in the Slack channel, you can ask questions, and we'll bring those to the attention of the speakers towards the end of their talk. If there's time, we go till about 9:15 Eastern time. I think that's about it,
Yeah, that's about it. Justin did bring up that this midwinter, it's really the last days of fall, but we'll let it go this time. Right? Thanks, Justin. Yeah, appreciate the snark there. Yeah, I don't think there's much else outside of join us if there's something else that you want to bring up. As always, our code of conduct is on the site as well. Please read through that so you know what to expect from us and what we're proposing as far as how the conference is going to flow. Review the talks and please join in. Let us know if you've got questions. Reach out to us on Slack, email. Heck, probably DMs on Twitter or something else if you want to, just to get our attention, or the YouTube comments as well. We'll be monitoring all those channels as the speakers talk. Yeah, but as far as introductions go, if we run around the room really quick, we have Santa, right? Oh, I mean Dave Lintner. Rich is bringing that up. Brian Glass, Abdullah Munawar, Ben Pick, and Logical or Stefan Edwards that have helped put together or curate this list of speakers that we have for the next couple of days. Those that we reached out to that were willing to speak, we're very grateful to all of them for giving us their time and sharing with us their expertise. We've got a wide range of talks, everything from diversity to NES, hacking or whatever that's going to be, Stefan, like that. I'm looking forward to all of these things. Yeah, I don't know. Any other comments from the peanut gallery? I mean, the organizers before we go ahead and start doing introductions. I know we're waiting for the first speaker to join, but if anybody else would like to chime in here before we jump into it, that'd be great.
Well, it's snowing where I am, so that's enough like winter for me.
Yeah, Justin, there's snow on the ground here in Iowa too. So I mean, it's definitely winter. I don't know where you live, but I know you get snow there in Utah. So it's winter.
Winter.
Yeah.
All right. Well, we have a little bit of snow, so whatever.
Yeah. No, I want to say it's been great planning and having this conference and letting the Absolute AppSec folks allow us to help them put this conference on. It's been a lot of fun. Ben and I have ran a few conferences in the past, and we definitely put this one up there, and it's definitely been a pleasure. Hopefully the audience enjoys it as much as we did in planning it.
Cool.
Just
Awesome.
keep rolling with it.
And apparently that's it, right? So thanks for joining. Yeah, we'll just go ahead and cut it now. No.
What I think we really need to know, when did Stefan last get a haircut?
Never.
That's
You know how I am. I either shave my head or just ignore my head for a couple of months, and then I get sick of having hair and then shave it all off. So, yeah,
It's just
exactly.
efficient. It only happens
2-3 haircuts a year. That's it.
Yes. So, yeah, I mean, are there any other logistics really that we need to talk about? I don't think there is. There are different streams for day 1 and day 2. So make sure and note that, as we, you're obviously on the stream today if you can hear us. If you're waiting for the one for tomorrow, then sorry, I guess. But they're both posted on the site and then also the email that we sent out to everyone that registered. But feel free to share out the stream as well. There's no reason that people that haven't registered can't actually view the conference. It's available to us all. And yeah, I don't know. We gave ourselves 10 minutes here, guys, and Ken doesn't. I guess we can ask Stefan, we can ask you about SolarWinds for the next 3 minutes before we start our talk.
I mean, did we talk about the charities real quick?
Yeah,
You mentioned that, but yeah, we can do it again.
Yeah.
I'll put the direct links to actually here. There's 2 links. That's for Toys for Tots, and the next one is EFF. So let me paste that in. Oh, that's in private. Never mind. Okay. EFF.
While Ken's posting that too, I also am pretty passionate about the Rural Technology Fund. Chris Saunders does quite a bit of work for RTF. So if you also were looking for something to give to, Chris helps disadvantaged rural youth get access to technology as well. So that's also something that would be a great place to give this season, as well as you're looking for things to give to at the end of the year. So
yes, please do. Please donate. I mean, it's been a hard year for a lot of people. I know I feel rather fortunate being in this industry because we're just busier than ever. Yeah. But let's give back a little bit and share. Right? We don't need personally anything from this conference other than we wanted to get together and hear some interesting topics. So donate to one of those charities or a charity of your choice, right? Like whatever you would have donated to go to a conference, that'd be great. And we'll go from there. But good. I think we have our first speaker queued up. Ken, I think I'll let you kind of take it away. We'll probably drop the organizer feeds here so you're not looking at all of us. As much as we want to admire Dave's glorious beard, we could do that at a later time as well.
All right, I'm going to start dropping people. So okay. Here we go. All right. And all right, so we're about to introduce Ksenia Piguero. I hope I've said that even remotely correctly. So this talk is going to be about shifting left for Electron.js security. We're really excited. Let me bring Ksenia into the room. Hey, how's it going? You're live. We're going straight to it. You are muted. Let me see if that's something on our end. Okay. All right. Cool. All right. So we're going to do a little audio test. Can we hear you? Oh, I can't hear. Let's see here. You should be able to edit your mic settings if necessary. Seth, you can hear me though, right?
Yeah. Yep.
Okay,
I can still hear you.
Okay. Let's see here. And thank you for everyone's patience. This is definitely going to happen. We have this little time to pre-stage, but it's live. So basically troubleshooting live. But let's see here. No, not yet. Sorry.
Yeah, we can't hear you.
How about now?
Yes.
Yes?
Yes.
All right.
Yes.
Awesome.
Perfect.
Good.
Great.
We are going to, do you want to share your screen for your slides, and we will make you the center focus and remove ourselves from the stream?
Okay, we can do that. All right, can you see my slides now?
Yes, we can. I'm going to add it to the stream, and we are going to drop. So, but we're in the room, so we can pop back in if you need us. But we're here, but we're going to jump off screen and hand it over to you. Awesome. Thank you so much.
Thanks, Ksenia.
All right, thank you very much. Welcome, everyone. I am very honored to be the first speaker of this great conference. So my name is Ksenia Peguero, and I am a senior research engineer at Synopsys. I've been doing software security, application security for over 10 years now. I used to be a consultant for about 7 years, and then I switched into just research. And on top of everything else, I'm also working on my PhD for George Washington University. And this work that I'm presenting today is actually part of my academic research. So not so much, well, partially part of my job. I'm combining everything, but yeah, that's going to be part of my thesis, hopefully very soon. I'm also a mother and expecting another child any moment now. So it is very, very close. I'm very happy to be here live today. And in non-pandemic times, I like to do things like ballroom dancing and diving, and maybe this will happen again, I don't know, a year from now or something like that. So I also tweet about security at Ksenia Dmitrieva. So I want to start today to talk about Electron JS security. And I want to start with an example of a remote code execution that was reported a few months ago in October of this year by Masato Kinogawa. And that was a remote code execution in the Discord app, Discord desktop app. So everybody who is gaming, who's using Discord for just like chatting with friends, may be very familiar. So if you have a desktop version of Discord, not your mobile version, then it is written in Electron. And what Kinogawa was able to do is basically create a link that an attacker sends to you as a user. So you're chatting with a bunch of people. You don't know who they are oftentimes in gaming. Somebody sends you a link with a video. The Discord app loads the video, just like many other Electron apps. And a lot of chats, like for example, Slack is also written in Electron, right? Like if somebody sends you a YouTube link, you don't even click on it, it loads automatically, and then you can click and play the video within the chat. And then once this video is executed, you basically it executes a remote code execution and starts an arbitrary program on your machine. So from the attack perspective, this is super slick and doesn't take much from the user at all. So let's look at the example here. There we go. So here's the video that Kinogawa recorded. So basically, yep, you have the screen. Somebody sends you a link. The user clicks start playing. The video starts playing. And then suddenly another application is executed. Like in this case, it's a calculator, right? So pretty scary. And what he did here is he combined a bunch of different small vulnerabilities in the Electron app. And as we go through this presentation, I'm going to talk about all the different security controls that this code execution circumvented and how he kind of linked to them all together to get the navigation, to get the remote code execution. So there was the context isolation, NXSS, and navigation restriction bypass. But first, let's talk about Electron a little bit. So if somebody is not familiar with Electron JS, it's a platform, a JavaScript platform for writing desktop applications. And there are a lot of applications that are using it. So if you are a JavaScript developer and you're using an IDE, there is a very high chance you're using one of these two, like Visual Studio or Atom. They're written in Electron. Project management tools like Flow are written in Electron. A lot of tools for design, games, social networking clients, again, desktop clients specifically, right? There's your WhatsApp, Skype, Discord, etc. And a lot of web apps also have their desktop clients, and the desktop client is oftentimes written in Electron. So why Electron? Why is it so popular? Well, it's an open source framework, and it's maintained by GitHub. So it is pretty, has a very good backing. So it makes it very popular for developers to pick it up. And what it does, it runs two main components. So it runs the Node.js and the backend, and runs Chromium browser for the front end. So it's basically a little server-side, client-side application that's running right on your computer. And both of the server-side and client-side parts are written in JavaScript. So both Node.js and Chromium need something to execute JavaScript. So they're using the V8 engine. And that is great. So they're sharing the same engine, but it also introduces some problems because they need to make sure the versions correspond more or less. Sometimes when Node.js, for example, gets updated and it needs a newer V8 engine, but Chrome hasn't merged to the newer engine yet, then the developers of the Electron have to make some decisions and maybe use an older version of V8. And if the newer version fixed a security vulnerability, that means Electron may be still running the older, more vulnerable version. So there are always these issues when you combine different technologies together. What are the pros of Electron? The development is fast because developers are familiar with JavaScript. Everybody who has written a front end, you can reuse the front end components from your website. You can use any framework like Node.js, like React or Vue or Angular. So all of that can still be used for Electron. Sometimes some of the server-side code can be reused as well for a web app and an Electron app. Some libraries can be shared. Of course, with Node.js, a lot of Node libraries can be reused, and there's a ton of them. So that's all great code reuse. And it is cross-platform, right? Everywhere we can run V8 on any platform. That means Electron app will run on any system. The problems with it is that, as I mentioned before, the version support sometimes is, some versions are behind on the latest version of Chromium or the latest version of V8. And then there are also performance issues, some high memory consumption, but they've been working on the performance specifically, so it's still pretty popular. How do all of these components interact in an Electron app? When we start an Electron app, what happens is, so we have operating system, we have Node.js running on top of it, and we have a native UI. You have your window that you can close, minimize, etc. So then, on top of Node.js, we have two large components. There's always the main process, and then there's a renderer process or multiple renderer processes, depending on how many pages in those windows are rendered. Because basically, the main process is your backend, and then the renderer processes are your front ends. So each of these components are written in JavaScript. They can interact in two different ways. So the main common way of interaction is IPC. In this case, there are specific modules. For the main, there's the IPC main component, and then for the renderer, there's IPC renderer component. It's an event-based system. So one component is listening for the events, the other component sends events. Very straightforward. So here I have the code. For example, the main component has the IPC main, and it listens for an asynchronous message event. The renderer, the client side, sends the event with some string as an argument, and on receive, the main sends another event, asynchronous reply, etc., etc. So pretty straightforward. However, there is another way to communicate, and there is the app class or app API group, as they call it. So usually the app component is only available in the main, and then because it has a lot of very sensitive functions. However, the renderer sometimes can also use a remote component of Electron, and then through the remote call the components that should only be available for the main. So that part sounds, from security perspective, it sounds like we are starting to cross some trust boundaries here. And what happens is, if we trust the renderer, if the renderer is only running the code that me, a developer, wrote, and it doesn't have any untrusted code, then yes, maybe we can let it use the app component and have access to other types of events, to other types of functionality. However, if there is a cross-site scripting in the renderer, or if renderer is loading a third-party component from the internet, from somewhere, that's where it starts to become dicey. So in my previous work, in my previous research for other JavaScript frameworks, kind of shifting gears a little bit here, I looked at the places where vulnerabilities can be mitigated in relation to the framework. So if we think about an application, and application has a vulnerability, this is kind of level 1, there is no mitigation in place, this is our baseline. The mitigation is usually some sort of security control, for example, a sanitization function, or like an encryption function, or something else, right? So that control can be placed at a different place in the application if the application uses a framework, from the framework perspective. So it can be some custom code written by the developer. The developer writes their own sanitization function, their own authorization function, or their own, random number generation function, which of course we don't recommend at all. Or this is level 1, so custom function. At level 2, we can be using an external library. So kind of same thing, it's a custom function, but written by another developer. A little bit more trusted because, hopefully this library is popular, used by community, more vetted. The next level is level 3, framework plugin. So if we are using a framework, maybe there is a plugin that does that for us. So for example, if we look at Happy.js framework, it has a bunch of different plugins that you can use. If we look at Express, it has a bunch of different open source plugins that integrate very, very tightly with the framework. And you just call the plugin, enable it set to true, maybe set a couple configurations, and it runs. The next level is level 4, where this mitigation is built into the framework. So we don't need to add some sort of third-party plugin. The mitigation is already part of the framework. And again, there are a lot of frameworks that have a lot of security built into them. So if you look at Sails in JavaScript, if you look at Django, for example, in Python, there are a lot of configurations that you can set and automatically enable. So this is great. That kind of lets developer think even less about security. And then level 5 is when the mitigation control is built into the architecture. So it could be into the language itself or into the platform itself. An example of that would be memory management in Java. So we all know that in Java applications, there are no buffer overflows. And that is because JVM takes care of the memory management. So that's awesome. That's really good. And my hypothesis for the research is that the closer the mitigation is to level 5, to the framework, or even maybe to architecture, the better, right? The less security issues there will be in the application. So for Electron applications, what I did is, I took that same framework and decided to see, okay, what are the common vulnerabilities in the Electron applications? And if we want to mitigate them, where are the mitigations? Where can we place the mitigations for these vulnerabilities? So what I did is I took 141 open source applications from GitHub, from the awesome Electron library. And it's a pretty wide variety of applications. So there are like Markdown editors, Messenger apps, like the Discord and Signal, database clients and password generators, and like all kinds of different apps. And I took an open source tool that's called Electronegativity, developed by Luca Carictoni, that scans Electron applications and reports a huge CSV file with a bunch of findings. And then I manually analyzed these results. And I'll talk about results a little bit later. And for these 140 something applications, most of the vulnerabilities reported fell into the 17 categories. And then out of those 17 categories, 8 of them, about half of them, were more commonly, there were more occurrences of that. So I decided to focus on those first 8 categories. So the first kind of top half. The total, I had 1,180 total defects reported by electronegativity. Out of them, about 460 findings were more like best practices. So they weren't leading to actual vulnerabilities. So there were things like, oh, you're using an older version of Electron. So like, okay, well, good information, but not really exploitable right away. So I discarded those because I was interested in things that can actually be exploited right away. And then out of the 1,200 that were left, I did manual analysis of all of them, manual review, and found 218 of them were true positives and about 1,000 were false positives. So, the quality of electronegativity is, an open source tool, but it has some limitations, obviously. And the problems are that it is an AST, it does AST-based analysis only. So it only looks at the abstract syntax tree. It doesn't look at the data flow. It doesn't look at the data propagation. So it doesn't track the data from sources to sinks. And that leads to a lot of false positives and false negatives. So for example, in this code here, we create a browser window, which is a very common functionality in Electron. That's how we create a renderer process, right? The browser window that will then render the client-side code for an Electron app. And it has some some settings. And so if we set a sandbox setting to a variable that we defined early and said, sandbox 1 set to true, electronegativity actually will not be able to identify and see what the sandbox value is set to, because it doesn't do the data propagation. Obviously, it's straightforward to a human to see like, yeah, it's set to true, but it will actually report a finding here because a sandbox is by default set to false. That's the default value of the sandbox. So that's why I had to do the manual analysis. So after I cleared all the results and got kind of the real data, as I said, I identified the 8 types of vulnerabilities and decided to concentrate on those. And going back to my question, I wanted to see where would the mitigation be for each of these vulnerabilities. If we wanted to have more secure code and help developers, where would we place the mitigation? So in this presentation, I'm not going to go about each and single one of them because we don't have enough time, but I'm going to look at 3 that are more interesting. So we're going to start with node integration. And the finding that electronegativity reports is node integration JS check. So what node integration does, and this is a functionality of Electron app that makes Electron apps makes them do what they're good at. And what their strong point is that when you run that client, when you run the client side of the Electron application, it can call Node.js services. It can call server-side code right away, and that's what makes it look like a desktop app. It's so super responsive, right? It can open files. It can listen to your network. That's what a normal desktop application can do, and that's great. That's what makes Electron applications Electron applications. However, there was a vulnerability, here an example, in 2018 in a signal messaging app, where, again, it's a messaging app. You're chatting with an attacker, somebody you don't know. They send you a link. The link executes cross-site scripting because the front end is written in React, and it was using the dangerously set inner HTML function, which is vulnerable to XSS because it doesn't do any filtering or escaping of the code. And then that code basically executes a remote code execution. And the reason why this is, like, if that happened in a browser, if you have similar front end loaded in a browser, the browser will not allow to start an app, or in this case, read its password file, because the browser is isolated and it doesn't have access to the file system. But with node integration enabled, that makes Electron applications able to do things like that, to read files. So how do we protect that? Well, we turn that node integration off. And unfortunately, in Electron applications, that node integration feature was enabled by default for many, many, many versions of Electron. So by default, it will be set to true. And then if you wanted to disable it, then a developer had to set web preferences for each browser window and say node integration equals false, right? And then for the web view component, which is another component that can also render untrusted code, it was off by default, which is great. But it could also enable, if there is a cross-site scripting, an attacker can create their own web view component and then set the node integration to true as well. But luckily, in Electron version 5, node integration was finally set to false. So that's great. The next security control. Oh, and so if we look at the mitigation level, right, this is the mitigation of this problem is part of the framework. And especially if you just change the secure default, it is on level 4, right? So it is built-in framework mitigation. The next one is very similar. It's called a sandbox. So when we run the render process, again, if we think about a Chromium browser, if we think about a regular, Chrome browser, each browser has that notion of a sandbox. So the code that is running in the browser is isolated from the operating system. It doesn't have access to Node.js API. It doesn't have access to third-party modules. It is isolated. Well, in Electron, it is not isolated. That sandbox of the Chromium browser was removed. This is like an additional control to the node integration. And for example, what it does, it disallows the require method. So you cannot call a third-party Node.js require components. And then you cannot call that app class through the remote class of Electron. So all your communication only happens through IPC, so only through the events that were defined previously and the events that the server side is expecting. So it makes the application even more secure. But unfortunately, by default, it was set to false. And again, to enable that in the web preferences, we have to say, sandbox equals true. So it's a mitigation that's built into the framework, but the defaults are not secure, and they're still not secure. And then the third one is context isolation. Again, it deals with protecting the render process from the main process. But in this case, you have the same JavaScript engine running the code on the server side and on the client side. And there is a vulnerability that is specific, a trick that is specific to JavaScript applications, and it's called prototype pollution, where an attacker, anyone can overwrite a built-in prototype function. In this case, for example, we have a preload script, and that is a script that's executed before the renderer process loads the untrusted code, or whatever code that from an external URL. And at that point, it still has access to all the Node.js components. So in this case, in this example, we have a set of safe protocols, HTTP, HTTPS, and we have this check, right? So if we are trying to open a third-party link, if the protocol is in the set of these safe protocols, then allowed to open external link. However, we rely here on this index of function. So, for example, if we send a link to like file and try to open a calculator, for example, this control should protect us. But if through the prototype pollution, we're able to override the index of function, which is a common function for all the arrays. So it's a function on the JavaScript prototype, and say, oh, this function always returns 1, then no matter what is the protocol of the link, if it's mail to or file, it will always return 1, which will be not equal to -1, and that will execute any link. And that is, again, because we have the same JavaScript engine, the same JavaScript environment, which is not isolated for the render process or for the server-side code that has access to other functions. So the context isolation, again, even if node integration is disabled and a render component cannot load the Node.js function directly, it can override the prototype functions. And this trick a little bit, it's a little bit more advanced, because then the developer or the attacker needs to guess what kind of built-in functions are used by the server side. But of course, if the application is open source, they can look at it. Even if it's not open source, it's a JavaScript application. It's pretty straightforward to open up the desktop the Electron applications once you load it, and you can see all the JavaScript source code there, right? So it's pretty straightforward to find that function and override it, and then just wait for the server side to call it in the right place. To enable context isolation, again, it's a simple setting. In the browser window, you just say context isolation equals true, or in a web view, once you create it, you add the context isolation as one of the web preferences to that. When the node integration setting was changed in Electron version 5, context isolation change was also proposed, but that never happened. Now it's still proposed for Electron 12, so hopefully it will be fixed by then. We don't know. So if we go back to the exploit on the Discord app, right? What actually happened there? Well, the node integration was not enabled, which is good. So that link could not call the calculator directly, right? But what was not enabled was the context isolation. And so what Kinugawa was able to do is, through prototype pollution, to override the test function for the regex and the join function for the array. And then they used the iframe embeds function with an XSS in it. So as I said, the chat would load a video and then execute it within the iframe embeds object. And the Discord app actually had a content security policy, so it would only allow videos from certain sites. Well, for example, Kinugawa had to find one of those trusted sites that had an XSS in it. One of them was YouTube. YouTube did not have an XSS in it, but it found some other site, and as you saw earlier in the video, was just like a 3D modeling site that would provide 3D models and have little videos built of them. So he was able to create that 3D model that also contained a cross-site scripting in it. And then when that cross-site scripting is running, because it's running inside an iframe, we would expect that XSS only executes in an iframe and therefore cannot have access to the top-level document. So to make it actually execute code on the user's machine, it has to be running at the top-level context. However, there was also a bug, basically in Electron, that allowed that navigation restriction bypass, because the event that was generated, that should be generated every time there is a new window opened, for some reason wasn't generated when the origin of the iframe was different from the origin of the main document. So that was the bug that Kinugava reported to Discord as well, and or to Electron, and that was addressed fairly quickly. How could we stop this attack as a developer, right? So one thing is obviously enable context isolation. So kind of one thing was in the control of developer. Another thing was a bug in Electron that was not in the control of developer, and that's something that Electron had to fix. But even if the context isolation was enabled by default, this bug wouldn't, this vulnerability and attack would not be possible. Well, and as I looked at all the different vulnerability types, the 8 that I discovered that were more common, most of them could be mitigated at level 4, and 3 of them could be simply mitigated by just changing the default to a secure value. So like very straightforward fix. Unfortunately, it takes a very long time to fix those things. As we've seen with like nodeintegration, that has been fixed. That's good. But other ones like context isolation or sandbox have not been changed before. And I understand, I mean, there are dependencies to make that change. That will be a breaking change, and that's why it takes a long time to come to this decision. But, we want to write secure code. So what I did as part of my research is I created a Visual Studio Code plugin, and I called it Electrolint, that basically helps developers to identify those locations in the code earlier in the development lifecycle, so that we don't have to wait until the framework fixes all the secure defaults or fixes the underlying issues. But maybe if we just nudge the developer and say, hey, why don't you set this setting to this value? Why don't you add a sanitization routine here and check the protocol, for example, of a function that you're trying to open, and it's it's coming from an untrusted user. Hopefully, that will make the applications more secure. So what Electrolint does, it uses electronegativity underneath it, so the open source tool electronegativity, and then it highlights the vulnerabilities straight in the code, as a lot of plugins, obviously, IDE plugins do. It highlights the location. It lists all the findings there. It also, it shows the description from Electrolint, but in addition to that, it also shows the mitigation advice. So very contextual mitigation advice. So in this case, for example, we're creating a browser window. It's you save the file, Electrolint runs automatically and says, hey, there is a context isolation JS check vulnerability here. Why don't you set the context isolation to true in the web preferences, so that you can avoid prototype pollutions. It also adds a little bit of information about what will change, what attack you will protect your code from. And the plugin is available on GitHub. Please follow the link, check it out, download it, send me your recommendations, tell me which you're thinking, and if you want to contribute, that's great. And with that, we can go into Q&A. All right, I do not. How can we go back into the discussion? Okay. So I stopped sharing. Yes, guys, you can still hear me. So if there are any questions in the chat, yes, I will be happy to answer them.
Hey, so sorry about that. We were actually trying to troubleshoot the audio of the next speaker, so I had to jump away. Thankfully, the volunteers helped let me know that we're back. Thank you. I caught all but the last like 6 minutes, I'd say, and up to that point, very informative. Obviously, Electron is something. Since I work at GitHub, I'm very familiar with the security flaws and the submissions we've gotten over the bounty with Electron. So yeah, thank you so much for your time. We greatly appreciate it. I'm going to check our feed for any questions. Brian or Abdullah, did you have anything you wanted to add here?
No, I'm checking the feed. I don't think I see any questions. Audience, once again, if you do have questions, you can just add them directly to the chat there on the right of the YouTube live feed.
A lot of people just saying hi and thank you and yeah, positive things, no questions. So
I think yeah, Stefan had a question.
Let me add Stefan to this.
Hey, Ksenia, that was really great. Thank you very much for that. We deal a lot with wallets and things like this in Electron, and I think there's you laid out all of the communication protocols very well, and it's very difficult for devs to get access to these sorts of things. And I apologize, we were testing an audio in another one if you covered this, but for the sorts of things that devs should be doing, I usually throw them at like Doinsex guide. I throw them at some of the things that Synopsys has put together, like that sort of thing. And again, I apologize if I just missed this, but are there like some ground truths that devs should be following? Because it seems like Electron is usually just a Wild West that people sort of, assume is secure because of course it is, and it really isn't.
Yeah. So every time, like my main point is that every time you're loading a render process, unless it is rendering just your built-in, index.html file that doesn't load anything else from the intranet, then you can enable your node integration, context isolation, not enable context isolation or not enable sandbox. But kind of my main suggestion to the Electron developers, to the Electron framework maintainers, is that we should turn on the secure defaults. And I would start with a render process that cannot do anything except for rendering the UI, basically. And then when you say, oh, that doesn't work for my app because I want the users to open a file, etc., then you go back to your kind of security dashboard and you say, okay, yes, this one window should be able to access the operating system. And you can do two things. You can set the node integration to true and say, okay, now you can do anything. You can load files, you can listen to the network, you can do whatever. Or again, you think, what are the actual functions that one window needs to do? It needs to open a file. Well, how about we just write one function in the preload script that allows to open a file, and then that renderer can call that one function, and then of course you check the arguments, right? What file it's opening, etc. But you don't allow everything else. So it's giving the access to the things that window just needs, and that's it.
And also too, it's interesting because so much of the Node.js ecosystem is broken. There's a lot, not because of things that Node.js is doing, but because people specifically target things in Node.js. There's quite a few like crypto key stealing library attacks that we've seen and whatnot there. But what sorts of things? Obviously, you work for Synopsys. They have solutions to these sorts of things. But what, as an academic, what do you see as the where that space is heading towards? Like, what sorts of things can devs do for that? Because that's also the other problem too, besides the lockdown issues that they have.
Yeah, and that's why I created that free open source plugin for Visual Studio, Beautiful. Right? So that's exactly why, right? And what the plugin does, it runs electronegativity, so the Doinsec guys, tool, but it also, instead of generating the CSV file at the end that you then have to manually analyze, and as I showed in the presentation earlier, a huge percentage were false positives, but that's fine. So what my tool does is it only looks at those top 8 that I identified that usually are true positives, highlights them in the IDE, in the Visual Studio Code, and provides the advice right there where the developer is writing the code at the line of code. And of course, not all advice is going to be true, right? Because the developers may say, "Oh no, we know we are loading third-party content. We are trusting it. We are loading it from our trusted server. Like that's what it's supposed to do. And so your suggestion is a false positive suggestion, and that's okay." But if it's not, then that's where you can fix your code, right? Early, and it's free, open on GitHub. So yeah.
No, that's great. And then also too, just because you work in the space, one of the things that we often run into is we like at Trail of Bits, we do lots with like fuzzers, property testing, symbolic execution, that sort of thing. And there's a lot of tools in the Node or in the JavaScript space to do some of these things, but they're sort of nascent, or they were like a research paper and things like that. Where do you see the sort of future for Node security going? Since I think there's some abortive attempts to try some of these sorts of things, and then they sort of stop. So like, as someone who studies it, what do you see the future is heading towards?
So my hope is that the future is going towards fixing the issues, right? A lot of the symbolic execution, like again, research in symbolic execution, research in Node.js security is targeted towards finding the bugs, finding the issues. If we look at research on JavaScript frameworks, it's all about performance and quality issues, right? There's not much research in terms of security of the frameworks. And I hope that academia will kind of catch up to the industry, right? In the industry, we've been talking a lot about, okay, we were finding bugs. Now it's time to build the security in to fix the bug, to provide the solutions for fixing the issues, right? So hopefully academia will turn into that direction. At least that's what I'm trying to do in my research, and provide the tools that either are native to the developers and they help to fix the things, or that are fixing the frameworks, or that provide something in the IDEs, or provide some sort of wrappers to the code that also fix the things earlier in the pipeline. So.
Yeah, it's amazing how exposing something in Visual Studio for a dev will get their attention when the whole of CI/CD pipelines and all the things we've been doing for years have not done that. But making it accessible and making it upfront is really great. No, but I did want to pick your brains on these sorts of things, because this is something we run into all the time, and you've done the deeper work here. So this was great. Thank you very much.
Thank you. Thank you very much. Well, it was a pleasure.
There is one statement here. Let me pop it up on the screen. So is it safe to say if a Electron app has access to files, then safe to say node integration is true, like attaching images if Messenger app, etc.?
Yes. So kind of yes and no. So Electron can have multiple render processes, right? And so if the process, if that happens in 2 different processes, you may have one process that allows you to attach a file, and so read something from your operating system, and then the chat, for example, is actually running in another process. Then the processes are isolated, and then it depends how they communicate, right? What they can kind of how the server side is written, right, in terms of communication. But yeah, it depends. It depends how the server side is written, basically. Because if you think about any IDE plugin, like IDE in general, like Visual Studio Code obviously has access to your file systems, or Atom obviously has access to your file system. If you think about a Slack, right, obviously has access to your file system, because you can upload as a user, you can download, etc. But basically, if there are controls built into what do you do with the links that are sent from a third party versus what do you do when you open the dialog and say, hey, select this file and send it to my friend? Yeah, that's where the trust boundary lays.
Awesome. Well, I think that Yep, I think that was the last question. So yeah, I just once again, thank you so much for your time and for your putting out this valuable information, since so many things are built on top of Electron, and we all have to be from a consultant perspective to a blue teamer perspective, it doesn't matter. We should all be focused on the security of apps built on Electron. So once again, thank you so much for your time.
Thank you for having me.
All right. Thank you.
Yep. Thanks.
Thank you.
Cool. I'm going to see if okay. So David Linder had dropped off. All right. So
looks like
this is Evan's talk.
Yep.
Right.
Can you hear me?
Yes, we can.
Yep. Okay, great. So I apologize. You're not going to get a moving picture of me. I've been having a number of network issues, but I think that's mostly sorted now, but to save bandwidth. Also, earlier today, I pre-recorded this talk in preparation for me not having internet. So if nobody is opposed to it, I'm going to play that, but I will be here to field any questions, because my pre-recording is probably going to be way better than what I'd be able to do live right now.
Yeah, however you want to handle it, Evan. We're just appreciative that you're jumping on and you're giving us some good info here, right? We're excited to hear what you got to say.
Evan is probably one of my favorite speakers. I heard Evan at PumpCon a number of years ago, and then I was lucky enough to actually get to work with Evan for a few years now at Trail of Bits. It's been an absolute pleasure. He has some of the best Evan, not to put any pressure on you, he has some of the best presentations that I've seen. And I also think that I'm glad that I take one for the team to have the bad talk right after Evan's, because everyone can just be like, my talk was terrible because it's being compared to Evan's. But I'm really happy that Evan could speak here, because he does some really wild stuff in his research, and he does some real wild stuff in his off time as well. So thank you very much.
This is going to cover a little bit of both. Okay, so I'll be here to field any questions, but I'm about to hit play.
Okay.
Awesome. And Evan, just real quick, we are available to you if you need to. There's a private chat you can post in there, and then also we'll be around even though we're off screen.
Cool, so. Thanks. And I'm actually not seeing on YouTube. Well, actually, you can full screen this whenever you need to. Yep.
Yeah, we're going to go ahead and do that. All right. We will hand it over.
My name is Evan Soltanic. I'm a computer security researcher at Trail of Bits. And today I'm going to be delivering to you a sermon on the indulgences of computational sacrifice, or alternatively, the superabundant benedictions of programming an absurd NES game. So, who am I? If you're really interested in the details, you can take a look at my resume on my website. And much like dairy products, you should always check the date in the corner before consuming the content. And as you can see, this is the resume that I submitted to Trail of Bits when I was applying for a job a few years ago. Now, the reason why I'm showing you the specific version is you might notice at the bottom there are some curious footnotes here. First, it's asking you to unzip the PDF of my resume, and you'll get something related to Git. It also says that it's a Nintendo Entertainment System ROM. Also, somehow the footnote here is printing out the MD5 sum of the PDF itself, and so on and so forth. So let's confirm some of these things. Sure enough, the MD5 sum that was in the PDF is correct. And also we can unzip the PDF and we get another PDF inside that has something to do with Git. File doesn't think it is a PDF or a zip, it thinks it's an NES ROM, so let's try emulating it. Sure enough, the NES ROM prints out the same MD5 sum. You can download this PDF on my website, as well as emulate it directly in your browser using an Emscripten compiled version of the NES emulator FCEUX. I apologize for my really poor gameplay. I recorded this really late at night. So I don't want to spoil all of the Easter eggs and gameplay of this. You can go and try it yourself. But in the remainder of this talk, I'm going to be talking about some of the technical challenges in creating this, and also how that can be applied to real work. So why is this resume different than all other resumes? Well, it's not because I'm looking for a job. This is a hobby. It's really fun to do these types of things. And it's really fun to program in a constrained environment. So for the remainder of this talk, I'm going to be giving you examples of how those constraints can teach you to be creative and learn things and techniques that you can actually extend to modern software. In order to do that first, we have to go back to Poker GTFO. I am a frequent contributor to and an editor of Poker GTFO. I've been involved with the publication for a number of years, however, not since its original inception. It is a roughly quarterly journal that is always released for free. You can see my mirror here, but we encourage you to make your own mirrors. There is no official website. We always release on paper first at a conference, when conferences, of course, are held in person. And then shortly thereafter, we release a digital version, and the digital version is always a polyglot of some sort. It's a PDF, always typically a zip, and something else. Ruby scripts, Flash, tarballs, JPEGs, all sorts of things that you wouldn't expect to be able to be a valid PDF at the same time that they are. I should mention here, POC stands for Proof of Concept, or alternatively, Pictures of Cats. I say this because other meanings of POC have become increasingly popular since this publication was originally named. So if you're reading this in public, particularly, and the laity doesn't necessarily understand that the double bar means or, so you can get some weird looks. Also, one of the most common questions we are asked is why, well, it appears as if you're numbering the issues in hexadecimal, but you went, you skipped over A through F. You went straight from 9 to 10. Why is that? Well, it's because we number in binary coded decimal as a tribute to the floating point unit of the HP Saturn architecture. We also have a number of publications you can purchase. They are published through No Starch, and in fact, we just released a third volume just recently. They are chronological collections of the articles that we have published. This is published at significant expense to all of the editors, and we don't make any money off of this. It wouldn't be fair to either us or the authors. So all of the proceeds go to funding those free print runs, and whatever is left over is donated to charity. So I encourage you, please purchase a copy of our faux leather-bound, gilded-edged books at any purveyor of fine books, or Amazon if you need to. but I highly encourage you to buy it directly from the publisher, no starch. So if you have a copy, please rise and open your hymnal to chapter 7, verse 6 for a recitation of some fine words by Ange Albertini. A file has no intrinsic meaning. The meaning of a file, its type, its validity, and its contents can be different for each parser or interpreter. So why do I bring up Packer GTFO? Before I created this crazy resume, in issue 14 of Packer GTFO, I got interested in creating a PDF NES polyglot. And this technique that I'm going to be talking to you about for creating this polyglot had been known for some time. It was independently discovered by Ange Albertini and Evan Turan. But I wanted to create, I thought it'd be cool to create a custom NES game, well, game in quotes, a ROM that when you ran it, it would represent recreate the title page and the table of contents for the issue. So in order to understand how all of this works, let's talk about the NES architecture. In the Nintendo Entertainment System itself, you have a CPU, a separate audio processing unit, and a separate picture processing unit. Inside the cartridge, there are typically at least 2 chips. There's the PRG ROM, which contains the program code, but then the sprites and graphics are stored separately in the CHR ROM. That's because the PPU only talks directly to the CHR. There's typically no way for the CPU or your actual program to draw directly to the screen. You have to use pre-encoded sprites in the CHR. That's typically read-only memory. Sometimes cartridges could have RAM, where then your program could actually write into the CHR and change the sprites on the fly. And there's also a mapper chip, which can actually do paging. Remember, this is an 8-bit system. You can't address that much memory. So what did games do if they needed more space? Well, the NES in the early 80s had memory paging before it was available in Intel processors, which is kind of crazy. So what the mapper does is you can write to a special address in memory. The mapper will intercept that and then page out different regions of PRG ROM or CHR ROM or RAM. But you could have any custom circuitry you wanted in the cartridge, as long as the CHR and the PRG worked as the NES expected. So this is why emulating cartridge-based systems, and in particular the NES, is so difficult. And that's because there were dozens of different mappers that came out for different games. Some of them were bespoke to individual games. So in order to write an emulator for the NES, you need to implement support for the logic in every single one of those mapper chips. This is actually how the Game Genie works too. So the Game Genie is basically its own mapper chip that intercepts all of the communication between the NES and the cartridge and can twiddle some of those bits if necessary. So given the fact that there isn't a single contiguous region of memory for an NES cartridge, right? It's split up between various banks of PRG ROM and various banks of CHR ROM or RAM. We need to have some file format to represent this. You can't just dump an NES cartridge to a single file. You have to have some sort of header to say what type of mapper is used, if any, and how many banks of PRG ROM, how many banks of CHR ROM or RAM there are. So nearly all emulators these days use a format called INES. So this is the format, relatively simple. There's some magic. You specify how much PRG ROM there is, how much CHR ROM there is. There's some flags, and so on and so forth. But there's also this optional trainer section toward the beginning of the file. And what this was used for was way back when, before emulators had support for all of the mappers, it was often necessary for a ROM where the person dumping the ROM knew that there wasn't mapper support yet. They could add custom code in the trainer section that would be patched into the PRG ROM to implement whatever functionality of the mapper was necessary. So this was kind of a hack to patch ROMs or hotfix ROMs so they could be emulated without necessarily having emulator support for the custom hardware in the cartridge. Okay, but these days, trainers are almost not ever used in NES ROMs. Okay, so let's now look at PDF. So, because remember, we're trying to create a PDF that's also an NES ROM. I have another talk that goes into a lot more details on the PDF file format and why it is so broken in many ways. That was given at Empire Hacking almost exactly a year ago, on December of 2019, I believe. It's on YouTube, so I encourage you to check that out. But the part that will be relevant here is that PDF typically just don't care. You can have 2 PDFs, and a PDF reader or interpreter or renderer will almost always ignore everything before the PDF header. The PDF header does not need to start at byte offset 0. Also, there can be junk trailing after the end of the PDF. So the PDF does not have to end at the PDF interpreter will ignore everything that happens after the trailer of the PDF. So one fun thing to play around with is take two different PDFs and just concatenate one after the other. Load it in one PDF renderer, and it might display the first one. Load it in another PDF renderer, it might display the second one, but almost no PDF readers will give you a complaint. So the thing to understand here is that, or the lesson from this is that under-constrained format specifications lead to what's called file format schizophrenia, or parser schizophrenia. That's where a single file is rendered differently by different implementations of the file format. So we're going to exploit this to create our NES PDF polyglot. So we have our INES ROM, we have our INES header that we talked about, and here we are going to enable that 512-byte trailer. Inside of the trailer, we're just initially going to fill it with zeros because it's not actually used for anything in emulation these days. But that gives us space to put our PDF header. And remember, PDF doesn't care, for the most part, about junk that happens before the PDF header. So we'll just ignore the INES header. Then immediately, we can create a PDF object, and PDF objects can contain arbitrary binary blobs. So we create a PDF stream object that has a length of the number of bytes remaining in the NES ROM. So we encapsulate the remainder of the NES ROM in that stream object, we end the stream, and then we include the remainder of the PDF. That's it. That's how we did it for Pocket GTFO issue 0x14. As you can see, it will actually run on real Nintendo hardware. And it's rendering the table of contents for that issue. And you can see that it's also printing out the MD5 sum of the entire file, not just the NES ROM part. So this is the same MD5 sum that is printed in the PDF. So if you think about this, the naive way to do this sort of MD5 cline would be to write a program that is able to read all of the bytes of itself and then calculate the MD5 and print it to the screen. But we couldn't possibly be doing that in this NES ROM because it doesn't have visibility into any of the bytes inside the PDF, which affect the MD5. So how are we doing this? It's a little bit trickier. How does that work? You can see we also did this in the in my resume. Well, if you take nothing else away from this talk, I hope that you realize that MD5 is dead and has been dead, and you shouldn't use MD5. Hopefully you already know this. Dr. Mark Stevens of Microsoft Research has done a lot of seminal work in breaking MD5 and showing that it's no longer a viable hash function with today's computational speed. So he released a number of tools in the HashClash project, one of which is called fastcall. So what you can take is a file or a prefix to a file. You can submit the file to fastcall, and it will emit two 128-byte suffixes that have a few interesting properties. So the first property is that if you append each of those suffixes to that prefix that you initially submitted to fastcall, they will have the same MD5 sum. But those two suffixes, A and B, are actually different. If you take a look, they differ by 1 byte. And in fact, it's even more subtle than that. It's not just 1 byte. If you look at those bytes, they only differ by their most significant bit. And this is actually guaranteed by fastcall. The most significant bit of the 60th byte is guaranteed to differ. So we can use this to encode the resulting MD5 sum without actually changing the MD5 sum of the file. So here's how we do that. We take a file, we find a good place inside of it to put this encoding. It's going to be, there are 128 bits in an MD5 sum, 128 bytes per collision, so we need 128 times 128 bytes to actually store this encoding. We split the file in half, and then we iteratively run those 128 collisions, one after the other, insert them in the file. Then, we can put whatever suffix we want after that, actually. Then, later on, when we're done with the file, we calculate the final MD5 sum. We see all of the bits of it, and then we can choose the resulting either A or B pairs to encode whether each bit was 1 or 0. Then we can use, in the case of the NES ROM, we can programmatically read over those, look at the most significant bit of the 60th byte of each of those collisions, and be able to reconstruct the MD5 sum. It's a little bit more difficult for the PDF version. You have to do some tricks with JPEG, but it's also basically uses the same technique. But that was 128 bytes times 128 times. And actually, if you were to do it naively to encode that, it would take around 32K to store just the MD5 collisions. To give you some context, that's more than the entire ROMs, the entire games for Donkey Kong and Duck Hunt. So how can you store all of that data? Well, it turns out with some clever encoding, you can cut that a number of bytes in half. But still, that's a huge chunk of space in an NES ROM, and it requires. It didn't require using a mapper for the Packer GTFO issue, but with all of the other ambitious stuff I wanted to do with my resume, it did require switching to using a mapper and doing some paging. So let's go back to the resume. So here's one of the things I wanted to be able to do. If you take my resume and you run this command, which is basically just looking at the 40 bytes starting at byte offset 0x1337, then you get this cute Easter egg. Now I have a number of hints in the game that I won't spoil for you for how to discover this, but this is what I wanted to be able to do. But that meant that I needed to have those raw bytes to exist at that specific offset within the outer PDF file. So in order to do that, I needed to play some tricks with the cartridge hardware. Specifically, I needed to use a mapper. Now, the first mapper I tried was the easiest one for me to use. However, it only had the option to swap out the entire PRG ROM at one time. But that presents a problem. The PRG ROM contains the code that we're currently executing. If that code calls into the mapper to swap out a different PRG ROM, the immediate next instruction is going to be from the bank that we're swapping in. So then you need to do all sorts of alignment tricks to make sure that the code in the bank you're swapping in is aligned with the code that you're calling from, and it's a huge pain. So I used a little bit of a hack to get around that, so I didn't have to make sure all of my code was aligned properly between PRG ROM banks. What I did was I created a little piece of trampoline code that I could copy into RAM. Then I would jump into RAM, jump into that trampoline. The trampoline would be the code that calls the mapper. It would swap out to PRG ROM bank 2, and then jump back into the code in PRG ROM bank 2. So the lesson here is that not all memory is created equal, but memory is memory is memory. Nothing prevents you in the NES from just copying code almost anywhere that the CPU can address and running it from there. The next trick I wanted to be able to do was implement a brainfu interpreter that implemented a quine. So this is brainfu code that prints out a copy of itself. And in fact, evidence-mechanics quine card is necessary for it to be a quine. If you change any of that code, it will not work. So this was inspired by a project by Vi Gray. He actually, I'm not sure if it's still in production or for sale, but he had these amazing NES cartridges with his brainfu interpreter that you could run on real NES hardware. The issue was it had a limit of 1,024 instructions, and that was mostly limited not by the ROM inside the cartridge, but actually by the RAM of the NES. It takes a lot of RAM to emulate this sort of thing. I believe he has since improved the memory efficiency and been able to double that number of instructions. But even so, my quine would have easily surpassed the RAM limit, especially given all of the other RAM I was using for everything else in my game. Moreover, my Quine was so large that it would require almost one ROM bank just to store it. So how could we fit all of that inside? How did I make it work? Well, the first observation is that there are a finite number of loops in the Quine. Second observation is that some loops only ever iterate once, or a finite number of times. And the last observation is that some loops are what I call monotone. They always iterate at least as many times as the last time that loop was entered. So what that allows us to do is, outside in a Python script, record an execution trace of this brain foo Quine and record how many times each loop executes. Then we can record which loops execute a constant number of times, which loops are monotone. And then for the monotone loops, we only need to store deltas, right? So if a delta in terms of how many more times the loop will execute given the last number of times it executed. This uses lots and lots of cheap ROM. It's cheap because now we can page it in and out using our mapper. And the only RAM it requires is less than 20 bytes. So like orders of magnitude decrease in RAM usage. So the lesson here is that not all trade-offs are between space and time, and not all space is created equal. So if I've inspired you a little bit to get into NES development or any type of like retro console development, this resource didn't exist when I started, but it's amazing and a great way to play around with things and get started. I encourage you to go to 8bitworkshop.com. They have a web-based IDE where you can program both in assembly and in C, and I believe also some other languages for a number of different retro architectures, including the Nintendo Entertainment System. They have a bunch of sample code, and it's a great way to get into programming in these constrained environments. The one tip I'll give you is that even if you are super familiar with assembly, I wouldn't jump in directly to assembly programming. I would start with C. And actually, if it is feasible on the architecture you're interested in, I would even start with BASIC. Okay, now you might balk with that because if you've ever programmed in BASIC, or if you open up a BASIC textbook, the first thing that you're going to see in chapter 1 is, you know, line 10, print hello world. This is so grotesque, right? Like, ugh. But if you skip ahead to chapter 6 in almost any BASIC book, you're going to see something like this. So think for a minute about the educational density of these few lines in the book. It's asking the kids to peek into the brain, the operating system of the computer, and poke some bytes, right? Think about how much that is teaching you about how these systems work, how, for example, the CPU interacts with the picture processing unit and the audio processing unit. And you can do it all in a language with very little in the way of an initial learning curve and with a lot of safety built in. So if I've offended you by this opinion, this hot take, which I hope I have, I encourage you to read more about it in Pastor Manuel Lefroyg's sermon concerning the divinity of languages in Pocket GTFO issue 2, chapter 7. There is a very famous Soviet film called Ironia судьбы или с легким паром. And it pokes fun at Brezhnev era public housing and architecture. And what happens is the protagonist gets pissed drunk, as one does in the airport, and mistakenly gets on the wrong airplane. He thinks he's going back to his home town of Moscow, but instead he lands in St. Petersburg or some such. He gets out of the airplane. He doesn't notice it's a different city. He goes to a taxi. He gives the taxi driver his address. And then the taxi arrives in an apartment building that looks identical to his home apartment building. He goes to his apartment number, which the door looks identical to his home. And sure enough, his key works in the same door. And all of the furniture looks very similar to his own furniture, so he crashes for the night. When he wakes up, your favorite romantic comedy ensues. So I'm going to convince you that the Soviet Union is Microsoft, Brezhnev is Windows, the apartment building is kernel 32.dll, and the protagonist is malware. So let's look at the anatomy of a Metasploit exec payload. All right, so malware payloads are typically constrained in many of the same ways that our NES programs are constrained. Right, they can't be over a certain size to fit within certain limits of the particular vulnerability that they're exploiting. And also, they don't necessarily want to have certain signatures. So they don't want to have certain strings inside. So malware will almost always use a hash to hash the strings for various things that it's looking for. And in the Metasploit exec payload, it needs to find certain DLLs in Windows when it starts executing. So it needs to walk through the linked lists in the Windows kernel to figure out which library is which based upon their name. But they don't just want to store the string kernel32.dll in their payload. That would be a dead giveaway. So they need to hash the that string. And the way Metasploit does it is by rotating every byte into a sum. And by the way, this is joint work with my colleague Mike Myers that was published in Pocket GTFO issue 13, chapter 7. So the reason why it's using this rotation hash is it is super succinct to implement in x86. It just takes 2 instructions, right? So it's super compact, doesn't use a lot of space, but it seemingly works pretty well as a hash. Well, it turns out that these types of non-cryptographically secure hashes are super easy to collide. You can do it with an SMT solver. It's almost instantaneous. All right. So what you can do is you can create another string, in this case, a prefix to the string, that when you apply Metasploit's hash, they both hash to exactly the same thing. So the moral of the story here is that some constraints cannot be overcome. Sometimes if you need to have a cryptographically secure hash, you're going to need more than 2 instructions to work with. So what can we do with this? Well, we can modify the in-mem order module list in Windows and add our own DLLs that we have named to collide with kernel 32 according to Metasploit's hash function. So when a Metasploit payload is executed on our system, instead of finding kernel 32.dll, it will collide with our honeypot DLL that we have included earlier in the linked list. So finally, I want to talk about PolyTracker, which is an instrumentation tool that we've created at Trail of Bits. And specifically, I want to talk about how some of the lessons that we've learned in programming in our constrained Nintendo environment can be translated to this. So the problem that PolyTracker and its associated tool framework are trying to solve is a given PDF, as we've seen already, can exhibit schizophrenia, right? So you could send it to a bunch of different PDF implementations, and each may behave differently. Adobe might crash, Poplar might reject the file as being malformed, MooPDF might just accept the file and render it. And it may actually contain an exploit that exploits a vulnerability in Foxit. So each implementation is interpreting the file slightly differently due to ambiguities, perhaps in the file format specification or the way the decisions they make about certain ambiguities in the file. So what we want to be able to do is automatically inspect both the file format and all of the extant implementations to automatically generate a subset of the file format that is likely to be safe across all implementations. So one of the ways that we do that is with PolyTracker. So what PolyTracker can do is it can take any piece of software, doesn't have to be a parser, but it will automatically add instrumentation to do what's called universal taint tracking. So we can run one of our instrumented binaries or an instrumented parser, and the PolyTracker instrumentation will keep track of which byte offsets in the input file correspond to which functions in the parser. In other words, what parts of the input file each of the different pieces of the code are specialized in operating on. So for example, we can see that the ensure solid xref function corresponds to operating on the trailer and xref sections of the PDF. The format object function is operating on PDF object dictionaries, so on and so forth. The way PolyTracker stores this taint information at runtime is using a forest data structure. So if we have this source code that PolyTracker would be instrumenting, there would be a runtime taint forest corresponding to a root node for every input byte offset in the input file. And then when we read foo and bar, they would each get their own taint node corresponding to those byte offsets. Now I'm simplifying a number of things here, but then if we were to assign baz to foo and bar, the taint from foo and bar is being unioned together. So baz is tainted by both byte offset 0 and byte offset 1. So we add a new node to the taint forest for baz. Now, of course, there are a number of optimizations where we don't always have to create new nodes, but still, over time, this taint forest becomes huge. And it can take a lot of RAM, and it also takes a lot of I/O to store, and then it also takes a lot of CPU to process, to do all of our analytics and post-processing on. So how can we make this more efficient? Well, one of the things that we can do is implicitly index nodes based off of their location in memory, right? We don't need to store pointers between each of the nodes if we can just store an index of where those nodes are in memory if they are all in contiguous memory space. This saves over 16 bytes per node in our data structure, and which is a significant savings when you're talking about this size of a data structure. But the thing to note here is this is similar to our solution for storing the brain foo quine. So I hope that this has inspired you to try constraining your programming. Memory is memory is memory. Trade-offs always exist, but are not immediately apparent. And if nothing else, there is divinity in all programming languages. Thank you for your time. And here's how to contact me. And you can go to sultanic.com/nesresume if you'd like to try emulating it yourself. Okay, so this is live Evan talking over this. There's about a minute of credits here. A few other people I want to shout out to that aren't in the credits, I don't think. Carson Harmon, who's my collaborator on PolyTracker. Also Sergey Bradas, who funded a lot of this work at DARPA. I'd like to thank all the Absolute AppSec people and the organizers of this conference. Logi for wrangling me to do this, and probably lots of other people that I'm forgetting. But I can field any questions you might have.
The sound, I'm waiting. I'm waiting for the sound. Oh, that's awesome. That was such a guys. That was an awesome talk, was it not?
Yeah, it was a great talk.
Thank you.
The way that started just from the very beginning was amazing, and then just continued. It was super fascinating. Didn't see the direction it was coming. That was really fun. We're asking.
I need to go play Zelda now, I think.
Yeah, there are lots of Zelda Easter eggs. And by the way, if anybody has played Mario Maker 2, there's a DLC that actually has a Link character that has like Mario physics, and I was really upset because like that was released right as I was releasing my own version of that. And so yeah, Nintendo scooped me. Mario physics are really weird, by the way, too. The Mario 1 physics are really odd and hard to implement.
Evan, I have to ask this question because I know that Langsec is controversial, but like with all the work that you do with parsers and things like that, would you consider this a Langsec talk? Because I think that's the question that everyone was brimming with, and everyone is like 2 or 3 people who know what I'm talking about.
I will answer that diplomatically, in that I think that the talk stands on its own as obscure some obscure Nintendo development, but yeah, I'll leave it at that, I think.
No, everything is amazing. I love the work that you do always, with all the weird machines that you find, you know, and it's absolutely a great thing. Weird machines is also a term as well for folks who are looking for things. But Evan does amazing work, but his PDF work and his NES work is always the most entertaining, I would say. So, but now, Evan, thank you very much for that.
Thank you for having me. It was really fun putting this together, or having a reason to actually make this slide deck. So,
yeah. I'm glad that we could have you, and I'm also glad to be the person after you, because now my talk can suck as much as possible and no one will notice because I just came after that talk and it's perfectly fine.
Yeah, Evan,
it'll be fine.
Yeah, you'll be fine.
Oh,
But yeah, we really do appreciate it.
Like, you know, it's just that was an amazing talk, and I really do enjoy everything that you did there, Evan. Thank you very much for that. Especially with
Thank you.
Well, good.
I don't think we have any other comments for Evan or questions.
Everyone's just busy Googling. It's it's going to be 2 hours of Googling between Evan and Logi here, right? As far as making sure we understand what's up, right? Or at least attempt to have a question. That's where I'm at right now.
My talk is not nearly as cool as Evan. So there's no sound. It's mostly me ranting.
No worries. No worries. All right. Well, yeah, if there's no other questions for Evan, again, we appreciate it. We'll go ahead and let you off the hook. But for now, anyway, we'll be in touch. Thanks again, and thanks for inspiring us on this one.
Yeah, my pleasure. Thanks a lot.
Thanks. All right. Next up, we have the one and only Stefan Edwards. And
thank God there's only one of me. I don't know how the world would survive if there were multiple of me.
I'm not sure how the world survives with one of you.
Worlds colliding.
Yes, very, very much so.
Brian Green's on that note too.
Brian jumped in just to say,
Having worked with you for what, close to a decade now, one and only is good.
All right, I'm going to put your talk up here, Mr. Logi.
Yep. Yeah, we're going to let you go to town. I've got Google fired up, so we'll see where it goes, right? At least this one's Wayward InfoSec Youth, so it feels appropriate.
This isn't modeling kilts or anything, is it?
No, this is about some of the things that Brian actually on the latest threat model that you and I have worked through, some of the more like dynamic modeling things. I took some of the ideas that we've had for a while, and I said, you know what, I want to sit down and distill them into a talk. I'm going to speed run a talk. I don't care how much of a rant it becomes, but I wanted to throw together some code. I wanted to throw together some ideas on how we can move towards more dynamic modeling of things compared to the way that we've done a lot of these sorts of things, which is like fairly dead and sort of static in a lot of ways. Yeah. No, Rich, it's not that bad. I promise I won't use any thesaurus or SAT word. But yeah, no, that's perfect. So good evening, everyone. Thank you very much. This is obviously my meditation on applying various InfoSec models to your programs, to your tooling, how I explore this space, and really trying to give your best blue steel as you go through and model things. We'll talk about the sorts of modeling that I'm interested in, the sorts of things that I do for the work that I do. It's not exactly the same sorts of models that everyone does. It's also slightly focused on the sorts of work that I do. We'll get into that. But there's quite a bit in here. And I really wanted to start this talk with the takeaways, not so that you can run away, although obviously it does give you that opportunity here. But I wanted to start with the takeaways so that you can really have an upfront view as we go through this entire talk of what I'm trying to give. Normally I have takeaways right after the intros and all that sort of jazz. But this talk, I wanted it in your face. And I wanted you to really think about this the entire time. There are really 4 domains that we can model and we probably should be modeling. Risk is the obvious one. And then progressing down the commonality scale here, we have threat, maturity, and then sort of semi-formal modeling. And I'll talk through what that actually means insofar as what I'm talking about here tonight. And I want to do it in a way that Brian and I run our threat models, which is to say data-centered, control-centered, really asking teams to walk through the connections, walk through what's actually released, what's actually impacted by these sorts of things. with a focus on practical techniques. A lot of the interesting things that we can do, a lot of the fun things that you'll read in papers, they're not necessarily the most practical areas that you can head towards. They're usually techniques that you can apply for a very specific domain. And I really wanted to go through and show how I've wrestled with some of these sorts of things for certain client projects, and also to make reference to other people that I know are working in the space and doing fairly interesting things. And if there's any spicy takeaway from this, I do think that we need to stop being afraid of domain-specific languages, and I think we need to stop being afraid of actually modeling things. Very often in InfoSec, we have a tendency to come up with Excel sheets, come up with CSVs, come up with diagrams, those sorts of things. And then we sort of produce these outputs, we produce these accoutrements, and then we literally do nothing further with them. How many folks have seen architecture diagrams? How many folks have seen risk registers, whatever, that are out of date, that don't match what their actual program is doing, that don't match the way that developers think, that sort of thing. And obviously, I'm a former Lisper. I'm not afraid of DSLs because every single Lisp program that you open is in itself its own DSL. But I do think that we need to start looking at APIs and looking at DSLs and understanding our models from that perspective, and start actually looking at our systems from the ground up. And I'll go through what I mean by all of this. If there was an ad for this, and what's sad is I actually took this advert from a school for wayward youth. But if there was an ad for this, it would really be this. If you have the inability to understand your InfoSec programs, if you're anxious about the state of your systems, if you're feeling despair and loss and those sorts of things as to where your data ends up, this talk is an attempt at showing a way forward and how I have overcome some of these problems myself, and the way that other folks who are working in this space do so as well. Obviously, there's quite a bit that I'll be going into. We start with takeaways, go through all those sorts of things. I want to talk about what actually is modeling. I think that is slightly different than what most folks will understand per se if they think about like maturity models, or they think about threat models. The way that I tackle these sorts of things are ever so slightly different. I wanted to talk about why we model, what we model, like some practical techniques, then get into the different areas that I'll be talking about, talk about what we get out of modeling, talk about some other areas, and then jump right into the last bit, into how do we actually apply these sorts of things. Who am I? If you've seen Absolute AppSec, you've heard me rant and rave before, but my name is Stefan Edwards. I am a practice lead at Trail of Bits. I go by a Twitter handle and everything handle of Logical. I basically work in defense, fintech, IoT, all sorts of stuff. My main areas of focus at Trail of Bits are threat modeling, vCISO, some programming language theory work. I work with symbolic execution quite a bit, work with static analysis. I also provide the sort of like InfoSec thuggery to Trail of Bits. You know, Trail of Bits has quite a bit of academic background, and then a number of folks who have joined in the last 3 years bring the sort of like on the ground background in policy, those sorts of things. And that's my main influence at Trail of Bits itself. And who is Trail of Bits? We are we're basically a boutique InfoSec consultancy. We do quite a bit of work. I think the interesting thing, obviously, Evan is a huge advertisement to what we do, but the sort of work that I'll be focusing on are the sorts of things that are probably more interesting this evening, are the sort of fundamental cybersecurity research programs that we do for places like DARPA. Some of the projects that we have, some of the work that we do comes directly out of DARPA funding, or it's DARPA adjacent, and we work very hard to make sure that those actually are usable by the community or usable by the larger InfoSec field, and that's the focus that we'll be talking on tonight. If you're interested in any of our publications, and I'll reference some of them as I go through tonight, there is what we can publish on our publications index here on GitHub. This talk actually uses a programming language that I wrote. It's called Caramel. It is a combination of a few different ML programming languages that I've worked in, a scheme dialect that I've worked in called Digamma, some existential sadness. So you'll see some things there. If you want to grab Caramel, there's a GitHub link in here. But we'll basically be covering 4 different forms within Carmel itself. We'll use type, which introduces like variants or tagged unions. So if you've worked in C before, or you've worked in Scala, and you've seen case classes in Scala, or a struct with a union within it within C, that's the sort of form that we're talking about there. We'll talk about constructors that come off of type. We'll talk about records, which are similar to structs or classes in other languages. And we'll talk about function definitions. And the focus of this talk was not to do things that would be super academic, super different. I really wanted to show that there are very simple tactical things that you can do in any language. I'm using Carmel because why not? It's my talk and I'll do what I want to. But you know, you really can apply any of these things to any language that you're working in here. And the point is that we need data ingestion, and we need some sort of framework that you can work in. You can start to think in the languages, and you can start to think with the models that you've produced for your program. Nothing in here is going to be generic that you can just walk away with and start to apply right away, right? The whole point is that we should be writing models, and we should be making DSLs for our own use. And so I stole my own language for that. So what do I mean by modeling, right? When I'm talking about modeling, I'm really talking about this. Like modeling languages, sure, it's an artificial language that can be used for sorts of things, but it's really this. The rules are used for the interpretation of meaning of components in the structure. Basically, we want to have something that we can describe the way that everything works in a consistent manner. And we want to express that information in a consistent fashion itself too, right? So it doesn't help if I can get everything into CSV, but then I need another programming language in order to process that, or I need another system in order to actually do the you know, whatever linking between those components there. So what I'm trying to get towards here is one system that we can use this. And the whole point, the only thing that you should be getting out of this really is to understand the meaning of this system, right? If you can model the entire system but gain no further insight into it, you have missed the point of modeling. So what my focus is here is some of the things that I've done, some of the crazy techniques that I've done for processing and actually understanding what a system means itself. And if you think about it, we literally make models all the time, right? How many times have you sat down on an application you're trying to understand, and you've literally sat there and drawn out all the routes, or you've generated data flows yourself, or you've made simple comments? This talk's whole point is to formalize these sorts of things. So you might see something in a code base that says this, right? This is actually very similar to another comment that I've seen before. Note, balance should be great, then withdrawal before execution, right? Now, it's just a comment. You have no idea what that actually means. There's all sorts of things there. We want to take those sorts of things and turn it into this. If you're old like me, you probably recognize this as JML. You maybe would notice that this would link into things like how Splint does its lightweight abstract interpretation. But basically, this is a set of invariants, a set of constraints, and a set of side effects that will occur within the application itself as we model things. So let's take this example, right? The original note was something very simple. Balance should be great, then withdrawal. So we have the misspelled withdrawal. Do we actually mean the withdrawal parameter? Do we mean the balance parameter? What do we actually mean here, right? And also, what does should? Like, what does should be mean? Does that mean it must? Does that mean the application will fail? Does that mean that we should require these sorts of things? What does this actually incur, right? And then at the end of this, what do we actually get out of all of this? So the note is trying to imply something. It's trying to add some very simple guidance as to what this function is doing or what this system is doing. But we're not really able to process this because we've sort of defined these sorts of things in a very fuzzy manner. We want to move away from that. We want to move to a system that enforces our spelling, right? We know that we're referencing this withdrawal versus that withdrawal, or this system parameter versus that one. We want to know that balance itself is modified. So we know that this function or this portion of the system will take a balance and will have a modification thereof at the end of it. We want to know something that like balance has to be greater than or equal to 100. We want to know that the withdrawal amount must be less than or equal to the total balance, etc. There are all sorts of rules that we're codifying here. And at the end, it's all enforced by our modeling language. And we ourselves no longer have to wonder about what we meant by when we scribbled a note that said balance should be greater than withdrawal before execution, right? And so the result is that we obviously have a better design, but now we also have a better understanding of the entire system. We can model this entire transaction flow because we have all these sorts of things here. And I know very frequently, if you look at this, if you deal with static analysis, if you're old like me and have dealt with JML, you probably have just seen this as like an invariant failure or a compiler failure or a refinement type failure, something there. But there's actually infinite output types that you can have from this. And if you take nothing away from this talk but this, it behooves you to start to look at what sorts of outputs you can get from what domain-specific languages you yourself can be writing or your team can be using. Obviously, this shouldn't be necessarily a private notation yourself, right? But you want to come up with something that your team and your workflows can actually work with. And there are really, the sky's the limits for these sorts of things, right? You can have process diagrams, all sorts of boxed visualizations, user process flows, any of these sorts of things. And you can then use those directly into your models themselves and start to understand where things break, understand the system itself, etc., right? We need, and the other thing is too, when we talk about models, we very often have this view of like a model car. It's a sort of thing we build, we send it down a track, and then we're done. We need to stop thinking in that term as this dead thing. We built a model and now it's done. And we need to start thinking about simulation. We need to start thinking about how we actually access our models, how we process things, how we move through our system and attempt to actually understand what we're doing throughout, regardless, and start to actually struggle with the sorts of processes and constraints that we actually have codified into our system here. Now, I took the very simple model that we have, the very simple JML, and I generated a very simple process diagram, right? We know that there's some user that does this, that does a withdrawal amount. We have some withdrawal process, blah, blah, blah. We see the side effect is that we update user balance and we return a result of a new user balance. We might also have some sort of constraint diagram similar to what I'm showing here. So we accept the request if withdrawal is less than or equal to balance. We reject in red over here if the withdrawal is greater than balance, right? And then we know that what the withdrawal process is itself. These are the side effects thereof, that balance is less than the withdrawal amount and result is now balance is greater than or equal to 0. We have all of these sorts of things from a simple model that we're also using to enforce at a language level what invariants, what preconditions, etc., should exist within the program. Now, I wanted to take a very big example of modeling. This is from the Votes report. Votes is a public report, a threat model that Brian and I did, and it's quite large. There's a number of components that we had in place here. There's a number of things going on. You can see that it's multi-cloud. There's multiple security groups. There's multiple things here. But at the end of the day, we had to reverse engineer the same sorts of things ourselves during our assessment. One of the things that I'll be talking about here is lifting versus extraction and how we actually get these sorts of things into our systems. But this is the why. Brian and I sat down and we spent, Brian more so than me, especially on this portion, spent a ton of time trying to understand what data flow talked to which diagram, which component talked to which component within which diagram, etc., and so on, in order to actually get these sorts of things out. And we basically built a mental model to hand back to the client and say, does this look right? Does this make sense? What I'm trying to do and what I'd love for folks to do and what folks are working on is to move away from this sort of reactive approach where we build our models later and sort of into a new approach where we're coding and struggling with them much earlier in the process, despite the sort of beautiful work that we can do with these sorts of things here as well. So why do we model? So as a red team person, I'm going to be honest. I like threat modeling. I like risk modeling because it's the biggest bang for my buck. I can sit in a 1-hour meeting and I can get 10 to 20 findings out. I honestly can sit down and really start to process, ask a bunch of questions, and then sort of lazily sit back and report on these sorts of things, right? In terms of the actual level of effort, you can really cover quite a bit of ground with modeling itself there. And from a very simple call, you can have folks reconsidering designs. You can have folks realizing that there's a bug. You can have folks realizing that there's all sorts of issues just from talking it out. In a 30 to 60-minute call, all of a sudden you have all of these sorts of things fall out. You have different stakeholders talking, that sort of thing. But in reality, the other thing too is it simplifies down the system under test, right? We're sitting down and actually saying, distilling out, this is what I thought the system should be doing. And obviously it's a simplification. We know that there's a whole host of things that go into it. But for example, when you are working with an HTTP connection, you don't sit down necessarily and think about the socket connection that's under handling it, any of the processes in between, the packets necessarily at the wire level, because you're focusing on HTTP. Modeling is the same way. We're sitting down and we're thinking about our systems. We're attempting to find ways to abstract them, simplify them, and then find issues from there. So what do we actually model, right? I think in decreasing order of commonality, threat, maturity, semi-formal, and then we're really often missing anything but the first one, right? And when I say risk modeling, I actually do mean modeling, sitting down and trying to figure out what is the likelihood X the impact or whatever you do here. You get into all sorts of discussions of NIST 830, 37, 39, blah, blah, blah. There's all sorts of things that we do to form simple models as to the impact of the system itself, right? And then you can move to threat models. These are the potential for impact, right? So you can look up NIST definition, which I link in here. But basically, when Brian and I are wrestling with these sorts of threat models, we're really just asking, what can an actor do with this system? What controls do you have in place to uncover that had happened, or that you actually had stopped this to begin with, right? Threat modeling is all about talking through the potential things that could go horribly wrong. And then we get to maturity modeling. There's all sorts of things out here for maturity modeling. There's many different ones. The ones that I'm most familiar with are like Hunt Maturity Model, Prisma from NIST. There's a few things in there. But basically, this is an attempt to sort of qualitatively understand how robust, how strong, and often, for my case, how centralized your controls are within a system. And there's a whole posture versus maturity discussion that we can have later in this talk. But when we're maturity modeling, we're basically attempting to figure out and describe in some way how robust the controls and the security apparatus of this application or of the system under test actually are. Now, if you're in InfoSec, those all probably make sense. You've seen those sorts of things. Where I potentially go off the rails is with semi-formal modeling. There are all sorts of models, and you can do things like binary decision diagrams, excuse me. You can do, all sorts of like state machine diagrams here, etc. There's all sorts of areas. Or you can do lighter weight models, right? You can do some sort of symbolic execution. You can do some sort of interpretation from there. But basically, we want to talk about the mathematical and logical models of a system's flow, right? And we'll get into that, hopefully. We'll get into that sort of discussion there. And we'll talk through some of the processes that I've had and I've been thinking about to actually get to that place. So let's talk about the actual practical techniques, right? I think we need to move away from just the sort of dead models. And Brian makes amazing dead models. I make incredibly ugly dead models there. But that's not the end of it, right? It's not that we just need to stop drawing things. We also need to stop doing things like creating JML and then running it only once, right? Or we also need to just stop ending up with systems where we have an Excel sheet, we just capture a bunch of risks, a bunch of threats, they maybe go into a thing, and there's no actual impact. There's no feedback back into the system. And what I'd like us to do is move towards a system that we have these sort of like living models. We have code, we have data, we have all of those sorts of things that you can actually update, you can run against your system, and you can check how things are actually going and make sure that your current model, your current system actually matches what you have coded, what you have worked with. And I understand most people who work in InfoSec, who work in development, will probably laugh at this notion, right? We end up in a situation where we try to design all these things, we try to make things better, but they often just end up sort of relegated to the side here. I know that's possible. I know that's a very likely probability, but there are ways to at least increase this flow and make this a lot easier for everyone involved. And I think there are some folks who are doing really interesting work in this sort of space. Hillel Wayne, he works in TLA Plus. He has all sorts of articles on how to do formal modeling with TLA Plus. He also works with some other languages, I believe Agda as well. But he also has this really great blog post on just how to model adversaries. So taking a very simple system and then modeling what an adversary within the system can actually do, modeling how far into the system that we actually can, and actually processing what an attacker could do with access to the system there. We have Tamarin, which is a cryptographic proof system, and Tamarin allows you to actually show what happens when keys are compromised there. Someone I've worked with is Redshift Zero. She's on Twitter, Jen. She does quite a bit of work with automatic threat modeling in a continuous fashion, and she's put forward her blog post on how to do those sorts of things. There's also PyTM, which is a great framework in Python, has some edge cases, and you can see what I've done with it in Kubernetes itself. But there's all sorts of interesting stuff there to work in a modern fashion with threat models that aren't the sort of like dead systems that we've done in the past. But in all cases, you actually end up defining a model in some sort of code or in some sort of system there, and then you wrestle with the implications thereof. And then we have the ability to actually refine our models over time and apply them back to the system itself. So it's a super fascinating space. So can we do better, right? I think Tamarin has the right idea. Tamarin has some idealized crypto systems. It has some idealized algorithms, basically without the underlying side channel issues maybe. But basically, you can place these within a system, and then you can do model checks within the system itself to see if you've misused keys or to see if you've misused like algorithms or those sorts of things. What I want to do is I want to start taking these sorts of ideas and applying them to InfoSec at large, right? I think there are many things that we can do with an idealized system, with an idealized data flow, that we can apply to a larger InfoSec practice in a domain-specific language itself. Obviously, your mileage may vary with these sorts of things, right? If you've done any modeling yourself, you know that there's no one-size-fits-all process here, right? So I really think that you maybe would need something with a lower level. Maybe you need something that is the same system, but maybe not idealized, right? You may have to struggle with these sorts of things. And obviously, you may have to refine how you work with these sorts of things. But having that abstract power there, having the ability to start with some sort of general primitives that you can start to wrestle with and codify your systems in, and then use those abstractions to build a larger program, build a larger system, is incredibly powerful. And we'll talk through some of these things. I also hope that you'll look through some of the links that I pointed you to. But there's quite a bit that we can already do without having to go out and codify all of these sorts of things and write our own DSLs. And I thought it would be fun to swag one. I thought it would be fun to take a stupid, wild-ass guess at what I would like to see there. Because why not? I think about this quite frequently. I'm always on assessments. I'm always wrestling with these sorts of things myself. And I really wanted to see, what would it actually take to codify some of these sorts of things? What would it actually take to get into this space and wrestle with it? So I thought we'd start with the simplest one, right? Obviously, this is the one that most folks will deal with. This is the thing that we can see very frequently. And what I wanted to show is there's a very naive approach that we can take here. let's just take something simple. We care about impact. We care about likelihood. We maybe care about severity. We maybe care about source and data. And we can define these very simple. We can have some sort of type that codifies data itself. We can have some sort of type that codifies component. And then we can just have a very simple structure that captures risk. And it has, you know, a very simple integer for impact and likelihood. We maybe have some links out to components and other things there, data, etc. Very simple risk model itself, right? And for simple things, this is perfectly fine. We can easily define an API that works around these sorts of things. We can generate graph viz, right? We can have some sort of graph risk function here. It's fairly simple to work. We hand it an array of risks, and we end up with some sort of graph viz object. We can obviously report out of this itself, right? We can convert risks into a CSV, we can convert risks into an HTML table, all the sorts of things there, and then do the usual stacking and grouping and searching there. But I think there's something fundamentally missing from this model that we come up with. There's something very simple that we could do here that we're not, right? We're not codifying what impact actually is. It's fairly manual process still here, and likelihood is as well. And it's completely disconnected from data, right? And we're not even codifying what impact is itself. Are we talking about like reputation? Are we talking about money? Are we talking about regulatory impact? What sort of impact are we actually talking with here? And this is something that I very often struggle with when we're codifying these things, when we're pulling up these models. Very often we start with something very simple and then we iterate very quickly into new DSLs or new models for these sorts of things. So there's a few different directions we can take, right? We could just add an API function that says calculate impact. It takes a reputational impact, confidentiality, etc. there, right? And that's fine. We give it a bunch of integers. We get an integer out. It does its thing. We don't necessarily know there. Now, what we could do is actually move away from that and make it a little bit more informationally dense, right? If you're given an integer, you don't actually know what the range of that integer is. There are ways of handling that with refinement types, but I haven't necessarily added them to Caramel yet. So a very simple way is to just actually use a variant type. We have some variant for very low. We have some variant for going all the way up to very high. And we give it that there, and we actually move towards an actual dense impact calculation there. But can we do even better, right? Let's look at data itself. So there are a few different things that we could actually handle for data itself, right? We could start to codify the data subscription. We could start to codify if the data is regulated, those sorts of things. And then we can add that information density to the type of data that we're actually processing. And then when we calculate impact, we can give it impacted data. We can maybe give it an actor, those sorts of things, and then receive back an impact itself. Now, obviously, we can go even more dense here. We can return back an impact object. Impact could be a type that said reputation, impact, etc. But the point is to start to actually think about the sorts of data that you have and process it at a deeper level throughout your entire system and model it that way. So the obvious alternate direction, right, is to go to an uncontextualized risk. We have impact and likelihood. We have some source, etc. And then we then have a contextualized risk that processes and captures these sorts of things. We can move in either direction there. And I have talked way too long, but we can move in either direction there. But basically, we can do whatever we need to for our workflows. So if you take this away, it's to actually understand that your workflows are what matter here. Codify your DSLs and codify your introspection to actually match your workflows there, and allow yourself to tinker, right? Don't think that you have to come up with an idealized perfect model the first time that you work with it. Allow yourself the space to actually process these sorts of things and handle things later as you grow and as you improve your program. So if you take away anything from this, it's that there's many things that you can do, but really you should experiment on your own information density, your own models, and process them as you need to. and make sure that they're ergonomic for your workflows and your programs as you need to process things and as you need to tinker with things themselves. So let's talk about threat modeling. I'll probably jump ahead in a second here. But let's talk about threat modeling really quick. We can capture potential impact to our system, and we can keep all of the things that we just defined for risk, right? We have enough for data, component, and impact itself. And we can reuse those to describe potential risks as well. So what I actually want to do is, what does this component talk to, right? When I go through in threat models, I am simply trying to capture who talks to what, where, how do we store it, how do we process it, and then actually have the outputs from these sorts of things be a consumable fashion. Those can be architectural decision records, they can be new architecture diagrams such as the one that Brian drew, etc. But we actually want to capture these in a single format that we can process there as well. So following down on how we process risks, we just have a simple uncontextualized threat here. We have maybe a system impact, an organizational impact. If you're familiar with threat modeling, you know what these are. But basically, we take all of the lessons learned from our previous model and throw them into this one here, right? And again, this is very simple for simple threats. If all we care about in our threat program is what is the impact to the system, what's the impact to the org, we can just use a very simple model like this, and that's it. Source, sync, and impacted data, we're absolutely done. Now, obviously, too, you can start to wrestle with this from the other direction as well. You can flip to mitigations. You can flip to remediation itself. And you can normalize all of this space here, right? You can process these things as you need to. But my recommendation is to start to work in ways that are very descriptive for you as well. And forget about normalization, forget about the sorts of processes that you have, and use the type system, use the class system, use whatever descriptors you possibly can to codify as much information at the logic level as you possibly can. All right, let's skip maturity for a second. Let's talk about semi-formal correctness. I think there's a very interesting space to be had here when in terms of semi-formal correctness, in terms of our models and the way that we work. And I know I'm butting up against time, but basically there are a few very different areas that you can work with. And if you are familiar with LangSec or you're familiar with some of the parser work that normally comes out, you may have already seen that as we build these definitional towers, we can actually build interpreters for these sorts of things. And there's an interesting paper that has just come out that's called From Definitional Interpreters to Symbolic Executors. But I think there's an interesting point here. Going back to Tamarin and going back to the simple systems that I spoke about earlier, I think there's a space to be made that we can start to interpret our primitives here from our risk models, from our maturity models, etc., and really start to define programs over the space of our InfoSec programs themselves. Obviously, a super spicy take itself. But I think there's also another direction that we can take, which is to have lightweight models that use things like design by contract and those sorts of tooling there as well, to actually process and handle things in a simpler method. And just before I bump up against time, the easiest one here is probably this, right? We have some sort of war game, we have some sort of risk that is contextualized, it has some additional information itself, we have some sort of component, and maybe we pass in a set of controls. And then we want to do a very simple match. Do we have a contextualized risk that is an SPII risk with an actor that is not restricted by any of the controls there? If yes, then we need to do all sorts of systems. Maybe we need to have an alerting process. Maybe we need to go through these sorts of things. But basically, we can codify from our models to a simple interpreter as to what things should be doing within our environments and how we process them further from there. Obviously, there's obviously quite a bit to unpack here. But when we have these sort of definitions, we can then start to simulate things ourselves in an interpreter fashion, in an executive fashion, and no longer do our war games and our tabletop exercises and those sorts of things actually need to be static processes that never live within our systems ourselves. We also can do symbolication of our components here, and obviously I'll hop off in a second, but There are all sorts of techniques that we can start to do as we go through and interpret our environments and as we go through and interpret our components to actually discover the constraints of even components that we haven't necessarily seen ourselves. And there's all sorts of techniques for those sorts of things that we can do. But in a nutshell, it's very similar to what I'm doing here. If you have a component, but we can't see that there's a load balancer in between, we simply add a symbolic one and start to collect constraints from there as well. So obviously, I'm taking a Langsec approach here. I'm looking at these sorts of things from a specification directive or this sort of space as well. Sorry, I'm looking at the chat as it goes. But there's a number of things that we can start to do. And if you think, yes, eventually, instead of programming in all the other languages, I program in my spec language, that is a risk that I'm willing to take. There's a number of things that we can do that we can extract to the common languages of our environment and process from there. All right, so I made it, I think. But are there any questions here? Anything that I can answer for folks? I know this is a very dense talk, especially since I talked so much in the beginning. But are there anything that I can clarify for people?
I think if we don't have any questions right now, what we can do is have folks post in the chat, or if you want, you can let everybody know your Twitter handle or anything like that. If they have any questions, they can follow up with you directly.
I'm logical everywhere.
Awesome. Thank you, Stefan.
Of course.
Greatly appreciate it. Seth, should I do the honors or should you?
I don't know. We can just all clap for Logi and then clap as Clinton comes in as well. Because I'm excited to hear Clint. I always love his take on things. So maybe we'll bring him into the stream. Clint, thanks again for being a supporter and and willing to speak. Stefan, thanks for that. Like I know there's a lot that we want to talk about on modeling, but we'll get to it eventually, right?
Never.
Never.
I actually want to hear Clint speak more than me because Clint
Let's just drop Stefan and we'll go to Clint, right? You know?
Yeah, exactly.
All the semgrep stuff, it's good stuff, right? So Clint is he works for R2C. He does the TLDRSec newsletter, which we greatly appreciate and read every time it comes out. Like there's always great tidbits in that. If you haven't subscribed to it, please do. But I think we're just going to turn it straight over to you, Clint, if you don't mind. I know we're running a couple minutes behind, but not too bad considering where we're at.
Yeah, I'm super impressed you're running on time so much. That's super hard to do. So props to you all. And I learned that it's logical. I thought it was like some play on like Loki and something else.
That's what most people think.
Yeah. Okay, I've been enjoying your work for a while, and this years later I learned how to pronounce your name. So
thank you very much, and likewise too.
Yeah.
Well,
cool. All right. Yeah, we'll let you jump into it. Excited to hear what you have to say. And I know we had an episode of Absolute AppSec with you recently talking about semgrep. So it should be interesting to see like the enforcement, the other things that you're talking about here. But I don't want to steal your thunder. So I'm just going to turn it straight over to you and let you go to town. Okay.
Cool. Sounds good. Well, yeah, thank you so much for having me, everyone. It's always a pleasure to hang out with the Absolute AppSec folks. I'm a big fan. So yeah, honored to be here. I promise this is the only slide that is annoyingly Christmas themed, but I just liked your artwork and I was like, oh, I figure I'll just borrow it. Yeah, and feel free to check out these slides. There's a link here and on the last slide as well, so don't feel like you have to screenshot or write everything down. But yeah, so basically this talk is 3 parts. So first I'm going to talk a little bit about why I believe secure defaults are significantly better than trying to find all the bugs. And try to give you like an intuition behind that, as well as look at case studies from a bunch of different companies who feel similarly. And then I'll talk a little bit about like a high-level methodology for how can we like target entire vulnerability classes to try to eradicate them. So it's sort of like like strategic AppSec program stuff. And then finally, in the third section, we'll get a little bit more tactical and talk about sort of tools and techniques to do it. So overall, that's the structure of the talk. So just very briefly about me before we get into it. Hey, I'm Clint. I work at R2C. This is our obligatory Zoom screenshot of our company. We're basically trying to build tools and processes that allow teams to scale their security. So lots of ways to do it, and we'll talk about some of the things later. But really what we're going to discuss today is all sort of like company and tool agnostic, like 90% of this talk. Before this, I was a security consultant at NCC Group. And before that, I was an indentured servant / grad student at UC Davis. Feel free to say hi on Twitter. Always happy to speak with people. And I do have a security newsletter called TLDRSec. So feel free to check out that as well. Okay, so I think that there's been some significant shifts in technology and how software has been developed in the past, say, 5, 10, 15 years. And I think similarly, we're seeing a trend in security as well, though it's still early stages, right? So we saw, going from waterfall development to agile, going from separate dev and ops teams to DevOps, going from on-prem to cloud. And I think similarly, I've been observing this trend across a number of companies where previously there was this focus on finding vulnerabilities. And going forward, I see this instead focus on sort of secure defaults and invariants, like holding things that must either always or never be true. So as a motivating example, I'd like to ask you, does this application have XSS? Realistically, you'd be like, well, I have no idea. I haven't seen it, right? So you probably have a bunch of questions like, what does the user control? What is the structure of the data? Does the web application filter it or process it? How is it stored in the database in terms of, is it stored as like an integer or a float or maybe, JSON or something like that? Maybe the database itself matters, whether it's Postgres, MySQL, or so forth. How is data returned from the database? Does the web app process it in any way before sending it to the user? And then how is it included in the, say, HTTP response to the user? Is it in HTML or in an HTML attribute, JavaScript, and so forth? Like you have all these questions, right, when you're trying to reason about the security of a system. But what if I were to instead say, well, we've established this secure default or say invariant where our front end is React and we've banned dangerously set internet HTML, which allows you to sort of opt out of the framework protections that prevent cross-site scripting. If we've done these things, then a lot of these other things are still relevant, but probably much less so than they were before. So we went from like having no idea about the security properties of our system to being like, well, I feel pretty good about this. Just by making this like strong guarantee and then enforcing it. So really, I look at this as two sides of the same coin, right? So on one side, we have finding bugs, which enables you to reason about sort of the security properties of your system and give you some sort of signals. And then the other is like, well, if we just say like, oh, there's this safe way that I know is like the security team has audited it, we trusted it. Like if we only do the safe way, then maybe this focus on finding bugs is not as important. You can also think about this as like task versus effort required. So for example, the units here are CHU or Clint's hand wavy units. So it doesn't take a lot of work to detect if something is either using or not using a secure library. This is pretty easy, but finding something that's potentially a bug takes even more work. Confirming something is a real bug takes even more work. And writing a proof of concept exploit that actually demonstrates that something is not just vulnerable, but exploitable in practice is even more work. So, why do these things that are very hard and take either a lot of analysis complexity or sort of manual human time when ideally we can get the same security wins, same security benefit with just less work? And fundamentally, I guess the argument I'm trying to make here is that detecting the use or lack of use of secure defaults is just fundamentally much easier than finding bugs. Maybe we've got some tweens in the audience who we need to connect with. And for that, I've included this meme. So broke is finding every vulnerability, and woke is preventing classes of vulnerabilities. Okay, so I think it's instructive to look at, okay, cool, like Clint, this is just your opinion, but what are these FANG company doing? Like the people And the companies who have, big budgets, large security teams full of very smart, talented people, there's executive buy-in, the company believes security is important, there's a willingness to pursue long-term strategic initiatives, and who generally thought of this a lot. So these are the people and the companies who I think it's very instructive to look at because, they've been thinking about this for a long time. So let's look at a couple of examples. So this is a talk from Scott and Isha I really like from AppSec Cali. This is how the Netflix AppSec team is prioritizing their efforts, and they sort of had 3 core initiatives: secure by default, self-service, and security partnerships. And notice how secure by default is, a big part and only growing over time. This is an interesting study from Microsoft, where basically they found that about 40% of the vulnerabilities they reduced between transitioning from XP to Vista was basically just like banning dangerous functions. So I think that's pretty impressive security wins for just like banning some functions. And there's like more details, but that's one of the key takeaways. There's a great book, Building Secure and Reliable Systems from Google, that you can download for free on this website that I've linked at the bottom. And they say that it's unreasonable to expect any developer to be an expert in security as well as building high performance robust systems, and be very vigilant when writing or reviewing code. A better approach is to handle security and reliability in frameworks, languages, and libraries. And ideally, the libraries only expose an interface that makes writing code that's vulnerable impossible. So I think that is very insightful. And maybe perhaps not easy, but we'll talk later in this talk about like how to do this rigorously and at scale. This is a great blog post from Facebook, who says, we invest heavily in building frameworks that help engineers prevent and remove entire classes of bugs when writing code. So there's sort of like a reverse or an inverse pyramid here on the right-hand side, where secure frameworks is sort of the base of it, but they also do automated testing tools, peer review, and so forth. So all of these things are useful and have value, but again, sort of the base, the most important part of this is secure defaults. And here's an anecdote so again, we've been looking at these like big established companies. This is actually from a hyper-growth Bay Area startup. They had like a couple hundred employees, but they were not massive at the time of this. So one of their security team told me, we were concerned about remote code execution in our Node.js apps. So we just banned eval, new function, and other things that could cause that to happen. They then wrote custom ESLint plugins that ran on every PR and just like blocked the pull request if it added one of these dangerous functions. And then they just didn't have to worry about these issues in their Node.js apps anymore. One thing my friend said that I thought was very funny is, you can get amazing security wins if you can be a bit draconian about coding standards. And obviously the caveat here is you need engineering buy-in. The security team needs to be supporting company goals and just doesn't naysay everything. So again, this is sort of within limits, but I think this is an illustrative example that this is very powerful and can be used by lots of companies, not just the biggest players. Okay, so hopefully I've convinced you a little bit about the power of secure defaults. So let's talk through a methodology for how you can target vulnerability classes. So this is actually an abbreviated version of a global AppSec SF talk my colleague Isaac and I gave. So if you want to see the extended, sort of longer, more detailed slides, feel free to check out that link at the bottom. Okay, so I just wanted to emphasize a little bit sort of the compounding effects of targeting bug classes rather than one-off bugs. So let's say you did a sort of time audit of your AppSec team, and you're like, okay, we spent some time, threat modeling, running security tools, cross-site scripting, and so forth. And let's say you thought, hey, cross-site scripting is really giving us a lot of trouble. Let's try to invest in, say, React or other secure defaults that allow us to basically kill this class of issue. So again, this is a lot of work, but if you were to do it successfully at scale, then all of that time you used to be spending on cross-site scripting, like finding, triaging, working with developers, education, all those things, you could then invest in another area, for example, say SQL injection. And by knocking out more and more of these pieces of the puzzle, you can gradually become higher leveraged and more systematically effective as an AppSec team, so you can support even bigger engineering orgs with the same or fewer people is basically the idea. Okay, so the methodology is not crazy complex. It's just, first, evaluate which vulnerability class to focus on, then determine the best approach to either find or prevent it at scale. we're going to select a safe pattern, like what does good look like, and then make it the default everywhere. We'll train developers to use this safe pattern, and then we're going to use tools to enforce the safe pattern continuously and at scale. So let's delve into each one of these in a little bit more detail. Okay, so there's not really a best criteria for selecting which vulnerability class to focus on, but here's some common criteria that I see different companies use. So one is you might focus on, say, the most prevalent issues, the things that your organization has the most of. Maybe you focus on the highest impact or risk. Maybe the easiest to tackle. For example, in your organization, some issues may just be like culturally easier than others, or maybe technically easier than others. Maybe your company has specific priorities that you want to listen to. But realistically, it's probably some weighted function of one or more of these. Okay, so first, in order to do this process, ideally you have like a strong vulnerability management program. So you want to know like what is your current state, like how are we doing right now? And then ideally, if your future efforts actually work, you don't want to spend 3 months working on some big initiative and then not have anything to show for yourself. So some of the things you want to track, for example, what's the severity of each vulnerability, which class is it cross-site scripting, SQL injection, or so forth? And ideally, like what's the source code responsible? Like what does the bad thing look like? And we'll look at that again in a second. So using this information, we want to build a list of sort of prior historical vulnerabilities our company has had. There's a bunch of sources for this you could look. For example, issue trackers like GitHub issues, Jira, and so forth. Maybe commit history. You could run a git log --grep and like XSS or SQL injection or so forth. Maybe you have static or dynamic analysis tools or fuzzing that's found bugs. Maybe a pen test reports, bug bounty, and so forth. So the goal, like regardless of how you find them, it's basically like let's build a list, a data set of vulnerabilities to review. And then we're going to review those for trends. So like let's look at all of our cross-site scripting, let's look at all of our information disclosure and so forth. And within one bug class, we're going to try to figure out, does the vulnerable code look similar? Do these types of issues tend to manifest similarly in code? So in an ideal world, we want to choose a vulnerability class that is widespread across teams and repos. It's high risk, feasible to get developers to fix, aligns with company priorities, and ideally is always broken in the same way. So realistically, probably you're not going to find too many issues where all of these are true, but ideally some of them are true, because that just makes it more impactful if you were to tackle those issues. Okay, so number 2, how to find and fix at scale. So here I'm just going to call out that, depending on what you're trying to find, there's many approaches, right? So sometimes like maybe pen testing or bug bounty is the best approach. Sometimes maybe threat modeling or a WAF or some other tool is the best approach. But in this talk, just because of time constraints, we're going to focus on, if there is known good or known bad code, probably some like lightweight static analysis is a pretty good approach. But again, depending on what you're trying to do, there's many approaches that could be good. Okay, so 3, how do we select a safe pattern and make it the default? So perhaps your company has internal coding guidelines or standards, or maybe your own personal expertise. Personally, I'm a big fan of OWASP, so there's great projects like cheat sheets or ASVS that say like, hey, like do these things, don't do these things. So feel free to leverage the great things the community has already done. And then the second half of that, once you know what good looks like, how do we make that the default? So one way to do that is to update all internal coding guidelines, whether that's referenced by the security team or the engineering team. So this includes like READMEs, docs, wiki pages, facts, and so forth. And one thing that I think is very powerful is actually working with the developer productivity team, right? So can we make the secure version have an even better developer user experience than the old way? Like, can we increase developer productivity and security? Because if so, I mean, like, why would they not do that, right? Because they can move faster and do what they want to do anyway. So that would be a clear win for both parties. Another tip that I think is pretty neat is if you integrate security at the right points, for example, in new project starter templates. So let's say there's a repo developers fork to create a new microservice or a new application within your company. If you just put the security mechanisms into there, every time someone forks it, you'll get this automatic widespread adoption without having to sort of convince people to bolt on security later. And a quote from Asta I really like is, hitch your security wagon to developer productivity. Okay, step 4, we want to train developers to use the safe pattern. So here are some tips for making communication successful, but obviously, it depends on your company and your culture, and there's no sort of one size fits all here. So ideally, what and why something is insecure should be clear, using terms that developers understand without security jargon. We want to convey impact in terms developers care about. For example, risk to the business, damaging user trust, reliability, uptime, and things like that. We don't want to say like, oh, you should fix this because SQL injection and that's bad, right? Like what is the actual impact here? And ideally, how to fix should be concise and clear. So we want to link to additional docs and resources with more info, but sort of what we show them initially is just like, hey, here's exactly what's wrong, and here's what to do about it. Okay, so step 5, we want to use tools to enforce the safe pattern. So again, there's many things you could do, but for this specific case, we're going to use some lightweight static analysis to ensure that the safe patterns are used. Okay, so that was a high-level methodology. How you go about that in your company may vary depending on your sort of ecosystem, tech stack, and so forth. But here's some tools and techniques to take that idea and make it a little bit more concrete. So specifically, we're going to get a little bit into how do we set up continuous code scanning? What are best practices there? And then how do we check for escape hatches in secure frameworks? So there's been a lot of talks for various companies about how they do code scanning. This is probably not a complete list. In fact, I know it's not. But here's like Twitter, Salesforce, Netflix, Cisco, PayPal, Coinbase, Datadog, Dow Jones, and many more have all talked about how they do code scanning and just sort of continuous security testing in general. But here's some things that I think pretty much everyone agrees on, for at least the most part. Most companies, the unit of scan is pull request, because if you scan every commit, it can be a bit too noisy. For example, work in progress commits that may not make it into the main branch. Why annoy people? Ideally, scan should be fast, just a couple of minutes. Ideally, you don't want the security linting to be significantly longer than the rest of the build steps, because then you're slowing down development and angering developers. And this lets you give them feedback while context is fresh. Like who doesn't like that? If you want to do daily or weekly longer scans, you can do that as well. But I would really lean into sort of fast scans as much as you can. I see many companies adopting 2 different scanning workflows, which I think is interesting. So one is sort of an audit capability. This is more for the security team as consumers, and this is more like just visibility into what's happening. So for example, the development team may be like introducing new code that's say parsing XML or doing crypto, and it's not necessarily a bug, but like the security team might want to know about it, so that maybe they get like an asynchronous Slack alert when that occurs. Or maybe conversely, there's also like a blocking workflow where it's like, okay, these are like high quality, high signal checks that if they fire, we're pretty sure they're right. And we want developers to fix those, and maybe we break the build to encourage them to fix it. Another property is we want to make adjustment easy. So can we make it cheap to add or remove tools and add new rules, new checks? So there's a bunch of insights from Google's tricorder paper that I think is quite excellent. So I encourage you to read it, that I've seen hold for a number of other companies as well. So ideally, the outputs of the tools you're using are shown within developer systems. For example, a pull request comment, rather than making them go to some separate tool. That's pretty bad developer user experience. The message you show users, ideally, again, is like clear and actionable. Like what do you do, what's wrong, and link to more info if they're curious. The infrastructure should capture metrics, what checks are firing the most often. Again, this might feed back into your system of like targeting additional vulnerability classes for what's most prevalent or impactful. How long are the scans taking? What are false positive rates? One thing that Tricorder does, which I think is very interesting, is developers can provide feedback in terms of like, this is a false positive, or I don't care about this. And it actually automatically evicts checks that are too low signal, which I think is pretty cool. Because if you are annoying developers too much, this causes ill will with them, obviously. And it also can be too much operational time for the security team to sort of triage all these issues. Okay, so that was about like how do we do continuous code scanning. So let's look at like what scanning are we doing in the first place. And again, if we think about, if we as a company are leaning into secure by default frameworks, all we really need to do is detect the functions that let you opt out of these secure defaults. So for example, dangerously set inner HTML. We talked about this earlier, maybe exec, eval, or other shell exec type things. Maybe unparameterized SQL queries or like raw SQL statements. And maybe things that are specific to your company, like, make super user or other things that you're like, anytime anyone calls this, like, I want to know because that seems dangerous. So one way to do this is an open source tool my company is building called semgrep, which is customizable, lightweight, and I think ideally suited for enforcing secure coding standards and best practices. So just like very little bit about it. It's open source on GitHub. You can check it out. It's LGPL, so use it however you want. It supports many languages, so Go, Java, Python, JavaScript, TypeScript, Ruby, and so forth. We're constantly adding more languages. Supports over 1,000 rules out of the box that are also open source on GitHub. It does not require buildable source code. So if you are running on partial source code, or maybe you don't have some internal dependencies and you can't resolve everything, like it'll still work. But I think the most impactful thing is that there's no domain-specific language you need to learn. Basically, if you're trying to target Python code or Java code, it just looks like Python or Java. And why is it useful for AppSec engineers or developers? I think every code base in every company has things that are like, this is how we write software and this is how things work. So maybe that's on like a wiki or in the code itself or in your brain. But there's probably things that you wish you could enforce at scale. And I think semgrep or any lightweight static analysis tool is a good approach for taking those ideas and ideally enforcing them continuously as sort of a GitHub action or a GitLab run or so forth. So I'll just give you like a quick example. So let's say we're like, well, exec is dangerous. Let's find all the times that happens in our code. Basically, this is one way to do that in semgrep. And if you want, you can go to these slides and like click on these links, and it actually goes to, I'll do that for like 2 seconds. Basically, if you ever want to play with semgrep without installing anything, you can go to the semgrep.dev and click on write. And basically, you can write a pattern here and see what's matched there. So let's say there's some like business logic in your company where you're like, well, hypothetically, we're a financial trading application. We want to call verify transaction before make transaction, because in our application, that's if you don't do that, it's a bug. So you can take that domain logic and business logic and sort of codify it into rules that run again on every commit. And so this is what that would look like in semgrep. So again, it's basically like, it looks sort of like the code you're trying to find. The $sign return is like a meta variable, which sort of is like a capture group in regular expressions. But yeah, the point is like, you don't need to learn some totally separate, unrelated thing. You can usually get up and running in like 10 minutes or so. Okay, so maybe you're bought into secure defaults, but you're like, well, like that's going to be a ton of work. Like we have this huge existing code base. We would need to figure out like what's the secure way? How would we flag when people are not doing that? So we're trying to make that as easy as possible. So we've created a couple of rule packs that are, of course, also free and open source, that are basically trying to detect like opting out of secure defaults. Like for example, here, this cross-site scripting pack, basically we went through the common web frameworks for Go, Ruby, Python, Java, JavaScript, and so forth, and said, what are all the ways to opt out of output encoding? Like, what are all the ways that you're basically disabling the security protections that your framework or library are giving you? And then we just flag those. So again, it's not necessarily saying this is exploitable, but if that rule packet doesn't flag anything, then you have reasonable confidence, assuming the rule pack is complete-ish, that you don't have cross-site scripting. And similarly with insecure transport, we basically tried to enumerate for common languages, what are all the ways to communicate over HTTP instead of HTTPS? What are the ways to disable certificate verification? Basically, like what are the bad, transport things that you could do? We just wrote lightweight fingerprints for all of those. So if you run that rule pack on your code, then probably you're communicating over HTTPS, or at least you're not doing anything obviously wrong. So we actually created some cheat sheets for these. So if you go to sort of the semgrep docs and go down a little bit, we basically created some cheat sheets to say, like, for Django, Flask, Java, and Rails, like, what are all the different ways that cross-site scripting can manifest? So I think this is useful for AppSec engineers as well as, say, security consultants, like people looking for bugs, because it's like, what are the bad things that I should be looking for? So, for example, server side, if you mark content safe, this does not escape HTML. Mark safe is one example of that, or like safe string. And basically we've enumerated, like, we spent a ton of time reading docs, reading various people's articles, and just trying to find, like, what are all the ways to, like, do something bad and dangerous. And we sort of enumerate each of these. And at the bottom, we have, like, this nice table, which is like, okay, like, if you were trying to enforce secure defaults, what would you do as an AppSec team? So you could say, okay, these are dangerous functions, ban them. This is what you should do instead. And then we also, where possible, have sendgrep rules that you can just trivially run on your code to see if you're doing the right thing. So again, this is still early stages, but we're trying to basically make it as easy as possible for people to, like, 1, know what the secure defaults are, 2, measure how they're holding up against them, and just, like, roll it out at scale. So it's not perfect, but I think it's hopefully a step in the right direction. And again, you can get up and running and doing this on your code today for free using open source tools. Another thing that I'm pretty excited about is we're partnering with OWASP. This is still early stages as well, but the ASVS and cheat sheets project, we're trying to sort of, like, see how we can sort of combine forces. So for example, we want to automatically verify, is your code compliant with ASVS level 1, or find code that, say, violates cheat sheets best practice, either in, like, CI or in your editor. So yeah, Daniel Cuthbert, Joe Bolin, Rohit, and many others have been helping us out with this. So another thing, we don't want to be, another security tool that just, like, points out a bunch of issues. Ideally, we want to enable people to do the secure thing faster, easier, and ideally without AppSec team help, sort of self-service security. So there is initial support for autofix in sendgrep. So here is an example. We have a GitHub action that you could say, hey, this rule matches all unauthenticated routes, and you could write a comment like, hey, looks like you're not doing a JWT auth check. Please add this code, and then you can just, like, click a button to add it in. So if you want to look at, like, what this rule is that actually created this, you can click here, and if you want to, like, see what it looks like, you can go there. So you can imagine, like, oh, this is how my company does accesses secrets. This is how my company, like, we used to use this one API, now we use this new API. All of these things you could codify and, where possible, add, like, an autofix. So say new developers could get up to speed faster, or, et cetera. But again, the principle here is the same. The tool doesn't really matter. And yeah, we have a VS Code extension as well, if you want some coverage in your IDE and not wait until just CI time to give developers feedback. And this has actually caught a number of bugs that I've written as well. This one I think is pretty tricky. So with requests library, if you don't pass a timeout, it defaults to, like, never timing out. So your code will just hang if the server doesn't respond. So I've done that many a time, and it caught it for me, which was nice. Okay, so let us wrap up. Just quickly, I think this was mentioned at the beginning, but if you're curious about keeping up with the latest and greatest in security, I have a free weekly-ish newsletter at TLDRsec where I try to talk about the latest, like, tools and resources and some work that I'm doing. There's a handful of people who like it, so maybe you will. And actually, one thing that just launched today, actually, which I'm super excited about, is I was collaborating with my friend Mark Manning, who wrote a excellent, super detailed guide on analyzing Kubernetes clusters. Yeah, so super detailed. I'd encourage you to check it out if you care about Kubernetes security. All right, so in conclusion, I think secure defaults are the best way to scalably raise your security bar. Killing bug classes rather than one-off bug finding makes your AppSec team more leveraged. The overall process is to define a safe pattern, educate developers, roll it out everywhere, and then enforce it continuously. And ideally, to do that, you have a tool that's fast and lightweight. sendgrep is one example, but you could use any tool. And again, focusing on developer user experience is very important. So if you like these slides, feel free to go to that link. Also happy to chat on Twitter or LinkedIn. And yeah, thanks so much for your time. I'd love to chat about it and ask or answer any questions.
Awesome, Clint. Yeah, we were. I'm seeing if there's any questions that popped up during it. I especially like. I've been playing more and more since we had our. And I realize my lights on are. I'll turn them on here shortly. But I've been playing with the in-browser semgrep tool. Just as I've been, implementing different rules and analyzing code bases, it's pretty powerful, right? Like I feel like it fills that niche. I know you talked about this already, but kind of that niche between full-blown static analysis and, hey, we need a good way to quickly assess whether or not we're doing the right things.
Yeah, it can be used for bug finding as well, and we have used it for that. But I think it does excellently fit the niche of like I know that this is bad. Show me all the places this happens.
Yeah.
Like you've probably done a bunch of consulting projects as well, where you're like either dynamic testing or code auditing. You're like, oh, this thing is bad. Show me all the places this happens. And for me, that was like super painful before. Usually involved like running rip grep a bunch of times and triaging like a million things.
Yeah. Yep. IDE searches and then spinning through thousands and thousands of lines of code to find the 10 where it was actually being used. Right. So, well, good. Like, how have you seen the uptick there? Right. Like, I know you haven't been at R2C long, but what has the response been from semgrep? I know you've been pushing it quite a bit, but how do you feel like the community is responding?
Yeah, overall, pretty well. Like, I think more positively than I expected. Like a lot of times, people just sort of proactively reach out and they're like, "Oh, hey, like this is super cool, thanks." Or like people write blog posts about it. Like Marco Lancini wrote an excellent post recently about running it on infrastructure as code, and I had no idea he was working on that until I saw it. Until someone sent me a link on Twitter about it. Yeah, I think. We see like a lot of people who aren't us writing semgrep rules. And I think what I find the most exciting and promising is developers proactively taking on semgrep for like enforcing like secure code, not really secure coding, but more just like best practices and like anti-patterns and like, man, I always have to comment on this in like my pull request. So like, I'm just going to write a pattern that makes sure that people do that. So yeah, because I mean, the dream is like, oh, the developers have already brought in this tool, and then the security team is like, cool, let's use that tool also for security, because then you don't have to fight anyone and get them to use it. So I'd say still, lots of room to grow, but so far it's been nice.
It's been good, and I'm also like I didn't realize that you were starting to work with OWASP for the ASVS standard. That feels very powerful to me, right? Like from a cheat sheet perspective, rolling that in, right? Like. Yeah, that's super exciting. That's all I wanted to say on that. Kudos for reaching out. I mean, is there any sort of timeline on when that's expected to be completed, or is it, do we need to go bug Brian Glass or somebody to go finish the OWASP side of things for us?
Professor Glass.
Professor Glass. Sorry. Glass.
Yeah, we've been, I would say early stages, but I think we'll probably see more of that in like Q1, Q2 next year. Yeah, we've been honestly, like it's something that's been on our mind for a while, but we've been sort of taking it slow because, we're like huge fans of OWASP. I've been attending conferences for many years and I don't want to be like, oh, here's this thing, let me like shove it in. So we've tried to been very like careful and respectful to be like, hey, like what do you all want? Here's what we're thinking about. And just trying to do something that like everyone wins from without trying to like, do something that people aren't excited about. But yeah, everyone we've chatted with has been like pretty stoked about it. And have been interested in contributing as well. So actually one thing we're thinking about doing is having like a mini hackathon where we're like, hey, let's try to get coverage of like this parts of ASVS or cheat sheets. And then like collectively as a community, we all sort of like contribute over like a week or two. So yeah, we're tentatively hoping to do that early next year. So yeah, I'll let you know.
Yeah, do. I mean, we'd love to promote it on the podcast or on, here, right? Anywhere that we're associated with. We're super excited about the project in general. So,
yeah,
good. Well, let's see.
And I had played with screen grab too, and I loved it. So thumbs up.
Nice.
Like recently, within the last 2 weeks. So
yeah. Yep. Well, good. Yeah, I think we'll give people then a couple minute break. I didn't check on Slack to see if there was any other additional questions.
No, there's no additional questions on Slack.
Good. All right. Well, we'll give people a 5-minute break. We've got Adam that's joining us here shortly, but we will we'll pause for a minute. Clint, again, thank you as always for coming on, contributing and giving us of your great knowledge. And again, I can't promote TLDRSec enough. Right? Like it's a great little snippet of code and security goodness that comes into my inbox. And so go sign up if you haven't done that yet.
Yeah, thanks so much. Always a pleasure hanging out with you all. And yeah, happy holidays and hope to see you soon.
Yep, great. All right. Thanks, Clint.
Thanks.
Thank you. Cool. So we'll take a 5-minute break and be right back at 7 p.m. Eastern time.
Okay. All right.
Cool.
All right. We've got about 1 minute, and it looks like before we're going to be we'll have Adam start his talk up for a Midwinter Nights Con. I just wanted to give a quick shout out to everyone that has participated so far. And also, if you have any questions, please, please, please feel free to drop them into the YouTube chat, join our Slack channel, any of the speakers. We're trying to allot a little bit of a time. I know we're going, talk after talk pretty quickly. 45 minutes doesn't seem to be enough, especially what we asked all the speakers to talk about. But it's also good, right? To give a little feedback and let them know what you're thinking, what you have questions on. So please jump in when you want to. Looks like Clint and Logi are talking in other chats as well, but we'll let Adam go to town from here and give his talk. I know he's talking about vulnerability management and handling hundreds of thousands of vulnerabilities. And I think I'm trying to remember, Adam. I think you. I don't remember where I've seen you talk somewhere before. We're all running in the same circle somewhere.
Yeah. Thanks, Seth.
Yeah. So
share my screen.
Yep, go for
it. Okay. Showing up?
Yep, we can see it. It's all you, Adam. Let us know if you need anything, okay?
Excellent. I appreciate it. Thank you for having me. My name is Adam Shaw. Today, I'll be talking about automating vulnerability management from scratch. Quick about me. I'm a principal application security researcher for Contrast Security. There's my Twitter handle and my website if you'd like to follow along with my work. I'll have updates regarding today's topic that I'll be posting at some point too. Hobby-wise, I enjoy spending time with my family, doing some home automation. I'm a KernelCon board member, which is a conference in Omaha, Nebraska, and I enjoy participating in CTFs. I have an extensive background in both development and application security, so I'm familiar with breaking and making applications. Today we'll be talking, like I said, about automating vulnerability management. We're going to discuss how I was brought into a corporate environment to build up their vulnerability management program from scratch. And then I've already open sourced some of what we're going to be discussing today. There's a few things I still need to clean up, remove corporate remnants from, and I will eventually post those online and drop that in my Git repos. So. I suspect that if you're in this call, you probably know what vulnerability management is. Clint went ahead and discussed it in the talk before this. Thanks for the lead-in, Clint. But if not, if you're new to the process, let me just describe it real quick. It's a cyclical process of collecting, identifying, classifying, prioritizing, remediating, and mitigating vulnerabilities found within your company environments. Wow, that's a mouthful, and it sounds like a lot, but it is. It's a circular process. It never ends. Usually it encompasses security operations, networking, all the software that you have installed in your environments, and all the software that you distribute. What vulnerability management is not, it's not intended to replace good security practices, and it's not the best prevention method for avoiding vulnerabilities. There's there's people out there who think that, hey, this is good enough, and what I'm here to tell you is that it's not, but it does help quite a bit. So with that said, let's talk about what we'd like to focus today. The goal is to learn each step in building the program, and we're going to start discussing how I accomplished this feat at a large employer in the cable services industry. So when I was hired, it was a large company. It had 3,000 employees, over 900 developers, millions and millions of lines of code. It was a multinational company, so we had developers in lots of different time zones. there was always mergers and acquisitions going on where we were inheriting terrible, bad code. And there was dozens of programming languages and, diverse environments, multiple desktop environments and multiple server environments. And this all existed already when I joined the team. And there was a need to also, we were a big company, we processed payments. And so there was a need to also be PCI certified. So the PCI 6.1 requirement says that you need to ensure all system components and software are protected from known vulnerabilities by having the latest vendor-supplied security patches installed. Deploy, this is the critical line here, deploy critical patches within a month of release. So as you can imagine, this presented quite a challenge. It was a lot to try to get everything done within. Whoa, sorry. It was a lot to try to get everything done within the month time frame if you had a critical release, especially if you had something that was on a team that you were unfamiliar with, or the code was just so awful, but it was so big that you couldn't update fully. So they told me, good news though, we already have an existing program. But with good news, there's bad news. The existing program wasn't great. This is the security operations program that existed when I arrived. If you are in the vulnerability management space, you might be aware of the CISA, the Cybersecurity Infrastructure Security Agency, vulnerability bulletins. I was doing this in 2018, not when I took this screenshot. And let me tell you quickly how this worked. First, every Monday, sometimes Tuesday, occasionally a Wednesday, and possibly never, they would come out with a weekly bulletin. And if you sense inconsistency, you're right. In 2018, these bulletins were few and far between. They were very difficult to get on a weekly basis. Or oftentimes we would go weeks without seeing one. I remember a particular stretch between Thanksgiving and Christmas where we didn't, or it was New Year's, where we didn't get a single bulletin. And then on New Year's Day, we received, it was like 8 at once. So that was kind of a lot of work and a lot of backfill that we had to work from. So the bulletin would come out, and then there was a woman in Atlanta who would furiously type. She would go to the webpage and she would retype it all or copy and paste into Microsoft Excel and color code and organize furiously, because she would do it on a Monday. And if there was no bulletin, she didn't have to do it. But if there was, she would try to get it all done. And then by Tuesday, we would meet up and have an hour-long phone call. And everyone would join in this phone call. The desktop guy would usually say, I'm going to wait for Patch Tuesday, which is Microsoft's weekly patch. And generally speaking, a lot of people only really responded to anything critical. So didn't have a lot of follow through. There was no tickets created. Everything was hand wavy. And we just had to trust that everyone was doing their jobs, which you'd like to do, but can be difficult. So there was a lot of existing issues. They only had a single source of vulnerability inputs. So when it was inconsistent, like I discussed, we weren't evaluating anything new. We had an incomplete picture. There was no guarantee that every stakeholder showed up. There was no guarantee that it was accurate. We had no follow through, like I discussed. Compliance wasn't involved at all. So how can we verify that this risk has been mitigated? I mean, that's part of the audit trail that we had to do for PCI. Additionally, it had significant overhead. It had a lot of unnecessary work between phone calls and somebody spending all day copying and pasting into Microsoft Excel. So it was overall, there was a lot of issues with this existing program. So I thought, okay, what would an ideal vulnerability management program look like? First, we'd have to have multiple sources to import vulnerabilities from. Ideally, we're getting as much data as possible. We also want a whole picture, right? We want to complete an asset inventory. We want to look at what we have on the network side of things, desktop, installed software applications, and any distributed software. We also wanted to involve compliance. We needed a compliance department to be involved. We wanted them to own the enforcement process so that the application security team, which I was on, could stay removed from enforcement. We just inform compliance. You do all the work of tracking down these people and making sure that they're getting stuff done in a timely manner. And ideally, we can automate that process a little bit. Also, we wanted to reduce overhead. No Excel spreadsheets, no hour-long phone calls. The hardest workers in this process should be Python and Jenkins, or whatever you want to use to do your own automation. After I thought about what an ideal vulnerability management situation looked like, I thought, challenge accepted. I'm going to do that. I'm going to take, additionally, I'm going to actually roll the operations existing process into my process, and I'm going to make their process better while creating the application security VM. So this was my course correction plan. I'm going to stay on this slide for a minute here. First, I wanted to automate asset management. We needed a holistic picture of our assets. Many times developers who are working on the same code for months and months and months, they don't even know every library they're using. I mean, how many times, have you joined a team and fully analyzed every single thing that they utilize? I mean, no developer really gets time for that. The developer gets hired, it's told about the business processes, gets their computer environment set up, and gets tickets, like start producing. So that's a problem. This process is even more important if you work at a large company that purchases other companies. You're inheriting their tech debt and you're inheriting their bad code. And especially if you buy a company and that software gets moved under a different team. That's additionally another concern. So if we can determine a way to collect all the information about our assets, hopefully we can match them to vulnerabilities. Speaking of vulnerabilities, we want to collect as many as possible. As I said, we would like to do it daily. So not on a weekly basis, like just constantly be updating our amount of vulnerabilities. If we can make this a process that's happening at near real time, then we also don't have to worry about having these big weekly meetings, especially if it's significant week. We're handing out a lot of work, which can be, it kind of hurts the relationships between the application security teams and your development teams. Also, it's important to see any changes in CVEs, whether it be like new descriptions, new scoring, right? If something changes the way a CVE was first posted and the scoring increases to a critical, I can no longer wait by PCI standards. I can no longer wait like 90 days to fix that. I'm supposed to fix it within 30 days. I would like to match the new vulnerabilities with the current assets. So I would like to do it with all current vulnerabilities and current assets as well. But then I'm not going to focus on like the history, but that's obvious first move is check all your assets versus like all the vulnerabilities that have ever existed. But then from then on, just match all your current assets with the new vulnerabilities as they come in. I'd like to automate the compliance oversight, maybe create a method for automatically ranking vulnerabilities by criticality. Clint, like I said, he discussed vulnerability classes that you could group them into. I'll discuss similar ideas. Highly critical tickets will have a 30-day fix window again. Everything else, could have a longer window. I dictated 90 days at the time. And then during the time frame which the ticket is open, feasibly I could create like steps for compliance, as in auto emails and escalations as necessary. And then lastly, I'd like to automate remediation closures. If a version gets updated in the asset management system to something that is not vulnerable, I'd like to potentially close a ticket. So an example would be if one library of jQuery was vulnerable to a cross-site scripting attack, and then the development team upgraded that library to a version that was not vulnerable, I should be able to tell that the vulnerable version no longer exists within our asset and automatically close the ticket that we've opened. That's a lot, but we're going to try to cover it, speed through this. So step one is asset management. This is the most important part of vulnerability management, in my opinion. You need to know what you even have, right? There's in these large environments, a lot of times it's difficult to know what you have available, what kind of assets you really have, and it can be endless. I mean, the amount of things that you can track here, can grow and grow and grow. It could be laptops. What kind of laptops have you handed out? It could be application code that you're shipping, enterprise applications that you're serving, like on a website. It could be servers, virtual machines, infrastructure. Are you hosting open source software? All kinds of things can come in as an asset. You can consider them assets. So how was I going to track all of that? Luckily, I worked for a company that knew the importance of asset management. I didn't create this program, but I probably used it to its fullest potential. And I even convinced them to open source it. At the time, there was a tool there that was mostly meant for the IT team called Asset Compliance Tracker. And this covered basically all servers and virtual machines. If you notice this underline on my slide here, this is actually hyperlinked. If you'd like to look at it, it's open source. At the end of the talk, I'll also give you the fully qualified URL, and you can copy that down. I'll make these slides available after this talk as well for anyone interested. This is called the Asset Compliance Tracker, or ACT for short. It's essentially a PCI monitoring solution for VMs and physical servers. So this was meant to be like a PCI tool, but I was able to utilize it to do a lot of vulnerability management as well. Basically, each server had a Chef compliance spec on it, one for Windows and one for Linux clients. And then each Chef compliance spec went and grabbed the following information. It grabbed the operating system name and version, which ports were open, which software was installed on that server. As you can imagine, this is super useful information to have, and it's a big piece of the puzzle for vulnerability management. So I have all that information available. So where do I keep it? Well, this is where I took this information, this data, and I sent it into a web page built on Docker using AWS Fargate. So the data is displayed in a web page, and it's completely sortable and editable. You might ask yourself, why does it matter that we're displaying it in a web page? Can't we just grab the data using the same calls that it's using? This is how it was already set up. So I thought, okay, I can use this data. And again, this is a one-stop shop for asset compliance. I'm going to touch on PCI here. I know that not everybody in the call is interested in that, but we had different segments. We segmented our servers and our assets based on different classes, A, B, and C. A was the most secure data because it touched PCI data. And B was more secure. It doesn't touch PCI data directly, but it interacts with A nodes. And then C, it doesn't either touch it or interact with A nodes. So that is the server and virtual machines. And why stop here at servers and virtual machines? We can include desktops, laptops, and phones as well. After all, IT has already, they've already tracked all that information into this ACT before giving them out to new employees. So I have management software already installed on the machines, so I can take this information and I can grab it all. So I'm grabbing servers, I'm grabbing desktops, phones, laptops, and I'm grabbing all of that data and I'm storing it. So it's gonna, ACT is gonna come back into this scope later, and this tool is open source. I highly recommend you go check it out if you're, looking to do this all open source. There are tools that do asset management as well. I'm not going to, I think that you could purchase something as well, but we didn't have the budget, as a lot of security professionals will tell you. We didn't have the budget to do this. So this is a homegrown tooling system. So again, this is a lot of the physical assets. We still need to figure out our own software. What tools and libraries are we using? Are we bringing in open source software? What does our infrastructure look like? What tools are we using on the network? Do we have anything in operations that we need to consider? This was where we had a little bit of a budget. And scanning your own software is probably best with a tool. You're not scanning for vulnerabilities here. This is all about asset collection right now. I work for a company that does this, so I'm not gonna, promote any particular company. There's plenty of fish in the sea. But the point of this is, like, the best way to go about scanning your own software is probably just using a tool. But what I want you to take away from this side is, what features you want here, because you want to know, does it detect open source software? How much detail are you provided? Does it detect standard libraries? Does it cover all the code bases your company uses? Does it detect changes in software? Remember that example I mentioned earlier about jQuery? If I change the software, does it delete it from its asset inventory? And you're going to have similar questions for your infrastructure scanning tools. Does this tool scope outside our network filters? Is operations, confident that this tool is capturing the full picture of their assets? If you can answer these questions, then you can move on from the software asset management portion. So we've covered, servers, virtual machines, desktop, laptops, phone assets, software, both internal and stuff that we ship to clients, and infrastructure. This was all done, again, at the company I worked at. We did all of this and we tracked it. We took ACT information, and we had Chef feeding it and IT feeding the information. And then we had some of our custom tooling, which I just talked about. And we actually automated it. We needed to create automation. So we started using Jenkins. Jenkins is an open source automation server, which ran some Python scripts that I created. And we stored all of the data into a MySQL server. Obviously, a lot of this process is pretty sensitive and proprietary, but I'm confident that a lot of security professionals could do this themselves, create their own script to save it to a SQL server. A lot of this work was actually setting up like the data framework and how I wanted it to look overall. So yeah, with my code release, I'll be using Python to create schemas for typical ACT results. These schemas will take and generate fake data. So I'll do that in Mongo. I know Mongo is not everyone's favorite, but it's the easiest way to do it. Okay, so that's automating asset management. Next, I'm going to talk about automating vulnerability management. So the weekly bulletins, they don't work as a good source of truth. They're inconsistent. The cadence isn't quick enough. The adjustments aren't included. If a previous CVE gets a scoring adjustment or an update to the description doesn't come back, it doesn't get re-referenced in the bulletin section. I actually have been told that nowadays it is doing this. So number 2 might not be a valid point anymore. I haven't been keeping up to date on this process as much anymore, but I've been told that number 2 might be fixed. So take that with a grain of salt. And number 3, there's not enough information in those bulletins. There's no version numbers. It's missing a lot of information. If you look at their actual schema, which I'm linked right here, you can get stuff like version numbers from there. So you could have, you know, you could have a string that you can actually search on when you look at your assets and determine whether or not your version is within the vulnerable range. If I look at the NVD JSON feeds, I can pull data directly from using their JSON schema, and they even have a modified .json that gets updated daily. So this is like miles better than the weekly bulletins, which was used in our existing process. And so I'm automating the vulnerability collection. This is a simple Python script which just, you know, collects all of it. First, I automate the import of every single file that existed because I want to check my assets against all previous vulnerabilities as well. And then I send that to a database afterwards. So inside of my database now, I have all of my assets and I have all of the vulnerabilities. And then I create a process that gets all the latest vulnerabilities at like 3 a.m., for example, that runs daily as well. So where else can we find vulnerabilities? I talked about how a single source of truth isn't a great place to look for vulnerabilities alone. There are a lot of different places that will post vulnerabilities, and I'm not going to go over all of them, but some of the best places can be GitHub issues. There's GitHub security advisories as well. You could find stuff in your tool outputs, Twitter, blogs, bug bounty write-ups. If you're staying up to date as a security professional, which you should be already because the landscape is ever changing, you will probably have a good handle on where to find more vulnerabilities. So I'm not going to get into automating that part of it. That's, you know, something that any professional can probably set up. So let's think about this as I'm automating this vulnerability collection. So I'm automating it from NVD. I'm automating, that's the logo for the Git Vuln Finder, which I found to be a pretty good online resource for searching databases for vulnerabilities, repos for vulnerabilities, and then any tool output. And I'm automating that with Python and saving it into a database, in this case, MongoDB. While I'm automating it, there's some important factors that I want to reference. The vendor, the product, the versions, the description of the vulnerability, the dates, i.e. is it discovered or has it just been modified? Because I can treat those differently. CVE information and criticality if possible. So here's just an example of how you could test criticality. If you wanted to do something like this, if it wasn't detected, you could have kind of a critical list and a blacklist where basically if it says remote, execute, arbitrary, root, something like that within the description, you might flag it as a probable critical. Meanwhile, something in a deny list would be like if it also says XSS, like if it's a cross-site scripting vulnerability and they use the words remote execute, because sometimes people write, I can remotely execute cross-site scripting. That might not be a critical vulnerability. And then this is just an example. I mean, it's all dependent on what your risk appetite is. Once you automate the vulnerability collection, then you have to assess criticality. One way to do that is, these 4 categories which we used. Are our systems affected? Are they internet exposed? What kind of category is it? Is it remote code execution possible? Is this an RCE? Are there public exploits available? That's a big one. If there are enough public exploits where ScriptKitty could go run this if they wanted, that would be something that would concern us. And operational or business impact. Are the affected systems free from any client customer moratoriums? And that would help us determine criticality. So now we've accomplished basically the first 2 steps. Step 3, this is a little more of a thought experiment here. You kind of have to follow along, and I do have some code for this. In particular, this is the code that I need to remove a lot of proprietary stuff from before I open source. But you have assets and you have vulnerabilities, and your assets have a vendor and they have a product name and they have versions associated with them. And your vulnerabilities, you're trying to, you have a vendor, a product, and a version, but you also have a description and a potential criticality. Matching is not an exact science. Oftentimes you still have to correct some data in the long run. The more efficient this step is, the less time you have to spend fixing data. As you notice, these 3 are identical, so you can do some sort of lexical analysis comparison between is most of vendor the same as this one, is most of product the same as this one, and does the version fall within, does this version, does the asset version fall within the vulnerable versions? And so if you have this information, you can potentially identify the vulnerabilities that you're susceptible to. There was a little bit of a training period on this, the matching algorithm, and eventually we got it to the point where we were pretty confident that everything that we said was a match was a definite vulnerability in our environment. Then we had a probable category which got manually reviewed, and then everything else dropped off. So now we've talked about automating asset management, automating vulnerability collection, and matching. So next is the compliance oversight. So now that we have identified vulnerabilities in our code, what do you do? Well, we can automatically create and assign JIRA tickets. The ACT database has a place where you can list responsible teams and managers for each entry. And so you can extend the other asset management to include this. Basically, this team developed this software, and therefore they are responsible for it, and this is their manager. And we maintain the managers as well, because if you need to escalate something to meet a compliance deadline, it needs to go up to a manager level. Another example, and that was software, but another example would be the IT owns desktop environments. So if you have Microsoft Word is now vulnerable on all of our desktops, this department is responsible for updating everyone and pushing out new Microsoft Word updates to every desktop, for example. Throughout each sprint cycle, the vulnerabilities that are then assigned out to teams who can include them in the next cycle. Highly critical vulnerabilities are marked to mandate a 30-day fix, and it can be included in the current sprint cycle per discretion of the manager. So again, PCI compliance told us 30 days. So if we have a critical vulnerability, that's something that can be potentially put into the current sprint cycle. And how can we assign kind of like other fixes, like beyond just the 30-day critical fix? We tended to deal with those 4 criticality categories that we discussed, and basically if it had 3 of the 4, we tried to keep it to a 60-day fix. And then anything less than that, we said was a 90-day fix. We often missed 90-day fixes, I wouldn't say often, but we miss them a lot of times, and that's where compliance would have to come in. But if we were mandating a 30-day fix or a 60-day fix, generally we had a lot of processes in place to ensure that happened. The particular at particular junctures, we would have automated emails sent out to the assigned developer, for example, and then the developer's manager. And if we were way behind, it would go to a director level or a middle manager above that manager. So that's the scoring rubric that we developed. And you can do something similar. That's I'm not pushing that on anybody. That's just how we did it. So next, we would like to automate the remediation closures. So once you have all your moving parts together, you can actually automate the remediations. Again, this is what I discussed near the beginning. If you have a vulnerable library X, if it's vulnerable between these versions and it disappears, we could have an open ticket status inside of our database, which that's what we did. And if the ticket has an open status, it also has the ticket number. And if it's disappeared, we can actually change it to closed ticket status and go out to the ticket number and close it automatically. So this was something that really made a big difference in developers' lives as well, because they were updating things, and as it got pushed out into production environments, their tickets would automatically disappear from their pipelines, which was another way to maintain that relationship. So here's kind of this is the compliance portion of this. We had a flow chart here, and it might be hard to see on a lot of monitors, but compliance basically, this was how they escalated if they needed to escalate. There was also exception requests that could be done, and those were sent through compliance as well. If a developer needed an exception because it was a breaking change, for example, that went through compliance, and compliance could issue a exception. So this is a little less fancier than my other slides, but it's pulled directly from our Confluence page. So future work. I'm very near the end here. So future work. I'd like to utilize machine learning for matching. I think that it would be cool if you had a pop-up that said, does this vulnerability match the asset, yes or no? And you trained your matching algorithm. The matching part was definitely the trickiest part. Like I said, we still had a lot of manual review. We had a definite bucket where we were definitely vulnerable to these, and then we had a probable bucket. And the probable bucket was a lot bigger than the definite bucket. So I'd like to get it to a point where you could grow that definite bucket and grow the not vulnerable bucket and just start to slowly shrink the amount that you need to manually review. And it'd be really cool if we could train it on the manual review part of things right here with does this vulnerability match the asset, for example. Sources. This is the asset management. Repo. I encourage you to go check it out. Also, my Git repo will have a few things listed under asset management and vulnerability management. I don't think I included that. Oh, I did at the end here. This is some of the sources I used for vulnerability collection. I talked about the GitHub vulnerability tool, the Git Vuln Finder, which I thought was I think is really nice. We use the JSON feeds from the National Vulnerability Database, where we were automating, grabbing everything that got modified in the last night, and then we were putting that into our databases. So, yeah, and then there's the bulletins link if you wanted to check it out. But that's how you can build your own vulnerability management system from scratch using very little outside tooling. Thank you very much.
Thanks, Adam. a little bit of feedback. I don't know if everybody else is, but it might just be me. Yeah, I was just going to check to see if there's been any messages. I was very informative. Let's see. Yeah, my biggest question there is like I don't know. So, some of the stuff that you were seeing from a vulnerability management perspective, right? You're really going a lot at the network side of things. I guess that the app plays into it quite a bit as well, right? But you're feeding, like most of the feeds that you had that you just barely called out were very much like, CVE focused. So have you seen much of a distinction between the number of vulnerabilities that are coming out of the app space versus the network space, or is it all just pretty mixed?
We saw we were a Microsoft heavy environment. So we saw a lot of Microsoft vulnerabilities more than anything, which is why the security operations setup was built in front of the application, the security side of things. We started getting a lot more application security vulnerabilities once we built this process, a lot more than we were ever handing down at the time. We had, like I said, it was millions of lines of code and probably 300 major applications at one time that were running. A lot of times, instead of building a feature to distinguish between two clients, for example, there was like a fork made, and another client like an entirely new code base. So it was a disaster in that regard, and so we had a lot of different things to scan.
Yeah, I still see that to this day, right? Walking into clients and they do something similar where they fork an entire, infrastructure and code base and then continue to make customizations. So
yeah.
Well, good. Yeah. Did we see anything pop up in Slack, Ken? I
do not see anything yet. No.
Okay. All right. Well,
Great.
good.
Thank you all.
Yeah. Thank you, Adam. Thanks for your time, your expertise.
Yes. Thank you.
Thanks, Adam.
Appreciate the support. We've got a couple minutes before we will drag in. Oh, they haven't even joined yet. Eric. And we'll have a discussion with Eric on
serverless security. I am actually really excited about this one. Or not that I'm not excited for all of them, but this one's about monitoring and that goodness. So actually being able to detect, exploitation of your serverless environments. So super interested to hear it.
Yeah, it'll be interesting to see what it is. I know Eric teaches at SANS. I mean, he did web stuff for a while, but I think he is doing serverless, either secure coding or something along those lines.
Yeah,
securing serverless environments. Go ahead, Dave.
He's like a senior instructor at SANS. Does a lot of the cloud security serverless stuff. He's actually was teaching one today. So hopefully there he is. He was able to get out of that. I know he was teaching a class up until 5:30 or 6 o'clock tonight. So
sweet, Eric.
Gentlemen, can you hear me all right?
Yeah,
we can hear you.
Sound great.
Right on. How's everybody doing?
Pretty good.
It's Wednesday.
I don't know. I mean, it's 2020, so that's about how I feel. So, but
still,
as good as we can do. Dave, I'm gonna go put my Iowa State shirt on, man, and I'll be back in a couple of minutes. All right.
Come on, bro. This is a Hawkeye State. You know this.
Well, appreciate the beat down in hoops last week. I knocked some bourbon down during that game, pretending it wasn't happening.
Yeah, Iowa's going to be a tough one for anyone this year, so I'm excited for that.
Yeah, they're good, man. At least it'll make the winter less painful, right?
That's right.
Wait, is this a sports ball conference or is this an app? I'm confused, you two.
See, Seth is just a soccer guy, so
everything else doesn't matter to me. You're right. You're right. I shouldn't cast aspersions, right? Like,
we start talking about the sports ball, and then we see people on the stream dropping. Like, I don't know
exactly. We see how it goes. All right. Before we lose the whole audience and it's just us, which is fine too. Eric, I think the first time Eric and I met face to face was at Black Hat Asia, wasn't it, Eric? When we hung out for a week because we didn't know anybody else there.
Yeah, that was fun. Boy, I wish we could go back there right now. I'll tell you that much.
Yeah, if we could get out of the country at any time in the future, but eventually we'll see each other again in person. Eric is he wrote PumaScan as well. There's all sorts of stuff that Eric does, but he's going to talk about serverless security for us today. And I know we're about a minute early, but you got your slides ready to go? Looks like you do.
Yeah, hopefully you all can see them okay. I just shared out the other monitor, so I think it looks good on my side now. Right on.
Yep.
So
we'll go ahead and we'll turn it over to you, and we'll monitor questions and things like that. But let us know if you need anything.
All right, sounds good. Yeah, thanks for having me on. I come from a dev background primarily. Went into AppSec, so I've done a lot of AppSec work. Ironically, in the last couple of years, it's been all cloud stuff. So my talk tonight is mostly, it's a little less AppSec. It's kind of a vision that I had of, well, let's assume that your serverless environment is compromised. Like, we would never write insecure code, would we? And put a vulnerable function into a cloud environment. And the approach I took was, let's assume breach and look at cloud native controls, what exists inside of all three of the big three clouds for helping security, incident response, networking folks get some visibility into these cloud services that are running these little micro functions that are starting to take over and power a lot of the application world. So hopefully most of you are familiar with these up to this point. AWS Lambda obviously is the most long-lived here. Azure functions and GCP functions are a little less documented from the security side. So what I intended to do with this research was double check that all the things I had read in Lambda were true, which they are, and then figure out the equivalent approach that I would take in the other two clouds. So I'll bounce around a little bit. I've got some demos and stuff that I recorded for a presentation I gave back when we could actually travel at RSA last February. And it's actually exciting to revisit this material and present it again because it's been a while. So what are the goals here? One, it's hard to reverse engineer an execution environment when you cannot actually SSH into it. So you kind of have to throw some malware into each environment and get a reverse shell. So we'll talk about how to do that. I made it pretty easy, along with some help from a colleague, Brandon Evans, to stand up command and control between all three environments. We'll poke around a little bit. We'll see where some secrets might be. The fun part is actually exfiltrating the authentication tokens from each provider's environment that they bootstrap with for you. And then we'll look at using those, pivoting into other parts of the cloud, and then take a blue team approach in the back half. What can we use for detection via logging and maybe locking down the environment to prevent some data exfiltration? So this was a fun little 2-month project, just poking around in all of the different functions. And I'll give you, a little 45-minute tour through the highlights. Overall, as you're looking at the environment itself, I have questions from a red and a blue team perspective. If you're trying to compromise this thing and break out, or potentially compromise the container, what user are we executing as? What OS is the function running in? What default directory am I sitting in? Where is the source code actually at inside of this container? What are in the environment variables? What service account am I running under? And then can I write to any of the directories inside of said function environment. So that is the project that we started with. And just like all things that I do at Puma, we pretty much name ours after cute little animals. So the open source repo that all of this research is sitting in is called Serverless Prey, and it's got code inside of it, some Terraform for Azure, because the serverless framework that we used for AWS and GCP wouldn't work. So it's a combination of serverless and Terraform to launch a Go function into Google, a C# function into Azure, and a Node.js function into AWS. So we wrote 3 different functions, picking kind of the, a native-ish language for each one just to entertain ourselves. All of that is out on the GitHub repo, out on our site. So feel free to poke around in there. Each directory, Cheetah, Cougar, and Panther, the names of the functions, has a doc that's got all the notes, all the commands, and everything that I'll walk you through here in the affiliated slide deck here. So step 1, deploy the functions. Step 2, invoke each one. They both take a host IP, which is your attacker machine, and a port that you spun up Netcat on. And all you have to do is invoke the function, and the function environment will give you a reverse shell back so you can actually run some commands and inspect the environment that your function is running in. So that's that simple. That's how you can get a shell into a function and poke around a little bit. The first thing we looked at was, well, what's networking like here? Do we have access to the internet? Clearly we do, because, well, the reverse shell worked. Are there any other controls that stop us from talking to malware servers or to AWS or GCP or Azure APIs or anything like that? Turns out no. Your function is deployed into a shared VPC inside of their serverless environment with full egress to the outside world. So you can do whatever you want out of the box. So it's important to realize, as a cloud security or even AppSec or DevSecOps practitioner, whatever your job title is, you're responsible for locking this down if you need it to be. Next up, let's inspect the OS a little bit. Where are we? Node runs on Amazon Linux 2, no surprise there. .NET Core, so I launched the Linux version of .NET Core, so I don't really deal with the Windows stuff much anymore. You can run it on Windows if you want to, but if you pick the Linux side, you're in a Debian Linux instance, running the Go function, you're on Ubuntu 18.04, at least as of the last time I tested this, which is within the last month or 2. Default directory, var task in AWS. You're on the root of the file system in Azure, GCP, or at SRV files. So that's where you will be sitting if you ever get a reverse shell into one of these. What user are you running as? AWS, it turns out, is the only one that thought running as the root user in the container was a bad idea. Both of the other ones, you're running as root in the container, which, even if it is isolated, by gvisor or Firecracker, whatever their micro VM technology is, it still isn't a good look. So AWS is the only one that took the time to generate a random user and run the function as somebody else. So that's the overall snapshot of the execution environment. Where's the source code? Because that's ultimately what you want. Normally, you're wanting to exfiltrate source code, read it, see if there's vulnerabilities, see what services it's communicating with, can I grab data from S3 or an Azure blob or a GCP bucket, whatever it is. So if you want the code, you go to var task in AWS, which is the default directory. In Azure, there's a little bit of IIS showing there. Home site root is where the Azure functions are deployed to. And GCP is also in the default directory, your SRV files directory. So a couple basic examples. Once you're in there, this is me in GCP, works for all of them. So we'll do an ls, what's in SRV files? And then you start to poke around, right? Oh, cool, there's the Go function, we can read that. Oh, interesting, there's a YAML file. There would maybe potentially be secrets in the YAML config file, which you can easily cat out and get access to. So you just start typing around like anything else inside of the function execution environment. The big difference here is eventually it's going to time out on you. So there's a little bit of a limitation on how long you can play around here before you get disconnected. Brandon Evans, the gentleman that I worked with on this, got annoyed by that. So he wrote up a shell script that actually, if your C2 channel gets disconnected, it auto reconnects back to the function again by just re-invoking it and standing up the C2 again. So if you use our script, there's a pray.sh script in there, you may not even notice that you're getting disconnected, which is kind of fun. Environment variables. Now I'll show you some other examples of this later. Basic LFI in any of these functions can give you the ability to just cat proc self environment and see the environment variables. AWS has some cool stuff in theirs. I'll show you that in a minute. Azure has even more cool stuff than AWS in theirs. GCP has hardly anything useful in their environment variables. So I'm showing you the Azure ones, which has a lot of encryption keys. There is a connection string to the Azure storage blob or the Azure storage account that it's actually downloading the function deployment package from. So you can actually pivot from the function into the storage account just based on the environment variables. It's got an app sites instrumentation key, which is all telemetry. So all your function metrics, you know, how long did I run for, what log files went in there, all of those fun things you can get to using the app insights key. There's an encryption key for kind of decrypting the incoming API keys that are auto-generated as well, which is fun. And then you've got the MSI, their managed service identity, secrets, and endpoint also live in the Azure Functions environment variables. We'll take a look at what that looks like here in a minute. So let's go to demo number one. This is the GCP side. So you're staring at an EC2 instance that I'm just using for the Netcat listener on a public IP. Let me kick this thing off here. We'll kind of watch how you can do this once you launch this project out the door. In burp, that's invoking the function to the public IP on port 1042, and we've got a Netcat listen. So that's how simple it is. We run ID. Yep, Google's definitely running as the root user inside of the container. We'll go ahead and see what OS we're running on. Matches up with the slides. Where are we? What's in the directory? So you'll see those same sort of deployment files from the actual serverless deployment package pop in here, and then lo and behold, we'll dump this YAML file out. So once you get them deployed, that's how simple it is to start poking around in the environment and investigating things. All right, so let's pop into the next topic here. Rather than hard coding credentials, which is kind of a no-no, right? We don't really want to deploy creds into the environment in order to access backend resources in the 3 clouds. So instead of doing that, they all offer an execution role that you can attach to the function, or a service account, if you want to think of it that way. Depends which cloud you're in. So AWS Lambda calls it the execution role. Azure Functions call it the managed identity, which is a virtual Active Directory user that you actually will never see in real life. They create it. It's kind of hidden from you in Azure AD, and then you just see this random ID that you can then assign permissions to for talking to storage, talking to Key Vault, and that sort of stuff. GCP's service account is what theirs run as, and theirs is almost the opposite of Azure. Theirs is just right in your face. Here's the default service account that we're auto-generating for you, and we're giving it full permissions to the entire project that this function is running inside, which is a little egregious from a least privileged perspective. Now, GCP's org structure, they very strongly push you towards using projects to isolate workloads. So they don't want you to use one project and think of that as comparable to an entire AWS account. But some folks do that. And this function, when it comes to life out of the box, has full read and full write permissions to the entire resource group inside of that project. you've got to do something to turn that off. So that's a gotcha. Something I was frankly shocked when the first time I spun a function up and realized that I could exfiltrate everything in the project from the function, which is pretty cool from a red team perspective. The other service accounts are very least privileged. Okay, so we've got a service account, functions alive. How are the creds bootstrapped into the environment? Where do they live at? Now, AWS Lambda, I had known where these live just from, reading the, Rhino security and seeing Scott Piper tweet all about Lambda. And so we knew they were in the environment variables. They're still there to this day, to my knowledge. So very simple to find. Azures and GCPs require a little more research. GCPs, they actually attach the instance metadata service that you would see on an instance, on a GCE compute instance to the function. So that's pretty well documented and easy to find. Azure's is not in the environment variables, and it's also not using an instance metadata service like their Azure VMs do. Instead, it's actually a couple of pivots to get to it. So I showed you the managed identity environment variable, and there is an endpoint in the environment variables to this local host URI and port. And then there's a secret also in the environment variables. Once you have those, you then need to make a GET request with the secret in the secret header to the MSI endpoint value, tell it which version of the MSI endpoint you want to pick. And also you have to give it which resource or which API are you wanting to talk to with the token that's returned. So there's a lot of work that goes in to grabbing or exfiltrating a token from their environment. Everything in Azure is using JWTs, which I did not know until I started poking around at this stuff. So all of their API access is JWT driven. The resource that I had to put in on that MSI request is the audience that ends up in the JSON web token. So this token that you just stole is only good for talking to the storage service. If you need to talk to the key vault, you've actually got to run your payload through again and grab another JWT scoped to the key vault service and so on and so forth. So in my opinion, Azure actually makes it the most difficult to exfiltrate all of the things from, because you've got to make a lot of different requests to that functions, to the function to get access to everything. So it's kind of a cool pattern that's inside of there. Flipping gears to Google. Google actually has a lot of different versions of their metadata service. Version 1 requires the custom header that you've got to set, metadata flavor to Google in order to talk to the metadata service to prevent SSRF attacks from easily extracting tokens from their environment. As it turns out, their beta metadata services, V1, Beta 1, there's also a .1 version that's still available on compute instances. Even though they're deprecated, they're still active. Their function environment does not have .1 active, but it does have V1, Beta 1 active out of the box. And you have to do something to actually turn it off. So if you don't want this very basic SSRF vulnerable endpoint to be available, we're just curling metadata Google internal / yada, yada, yada service accounts default token to get the OAuth bearer token for the environment back. In every single function, you have to set the disable legacy metadata server endpoints environment variable to true to block requests to the vulnerable implementation. So that was kind of fun to run into as we were poking around with this stuff. Okay, and then we have tokens. What do you do with them? How do you use these things to actually do some damage in the account? Now, AWS, again, is the easiest here. Their values are in environment variables. All you do is set 3 environment variables in your shell and you're talking. Azure's and GCPs are a little bit harder. You actually have to craft REST API requests, which anyone that's worked in dev and AppSec long enough, you're probably cool with this, but there's a lot of red teamers out there that are not comfortable writing raw HTTP requests. And that's kind of what you have to do in their ecosystem because they're returning OAuth bearer tokens or JWTs to you. So on the AWS side, this is how simple it is. Set 3 environment variables to what you've dumped from the environment variables in the function, and boom, you're stealing the image of the Panther right out of the S3 bucket from your laptop at home instead of from inside the function. So that's how simple it is to use. As we look at some of the other options here, I'll show you the demo of the Azure side here in a sec. As a blue teamer, you're immediately concerned, right? How long do these credentials live for? If you remember, the signed JWT in Azure, that's not changing. Unless you go in and just revoke the permissions from that managed service AD account, it's going to live for however long you signed it for. GCP functions is an OAuth bearer token, same drill. So those were really easy to see. Google's 30 minutes, that's it. So if you're an attacker, you better do your damage really quickly before that thing expires. Azure and AWS, way longer. So the JWT in Azure expires in 8 hours. Does that seem excessive for a function that runs for 300 milliseconds? It seems odd to me that it lives that long. That's just the way the platform is drawn up. We cannot change or modify that. It's not configurable. So that's just, you have to live with it. AWS is even worse. And of course, it's not documented whatsoever. Either their creds, their access keys that you dumped, live for roughly 12 hours. And the only way that we were able to actually find that out is just by issuing a request, write up a little job that runs every hour and say, hey, are these creds still valid or not? And eventually after 12 hours, they expired. So you've got some serious time on your hands as an attacker when you steal the creds from a function that runs for 300 to 500 milliseconds in Azure and AWS to use them and exfiltrate from the environment. Next, we looked at persistence. So these functions are supposed to run for 300 milliseconds and go away, right, when they're done. There shouldn't be an opportunity for persistence here. As it turns out, that's not exactly how they work. So there's a concept of a warm environment and a cold environment. The cold environment is fresh. There's nothing in it except for the function, and then it lives for a while. So even though your function only ran for 300 milliseconds, when you do something like write a test malware sample, we threw the iCar virus down into the temp directory, for example, let the function go away, and then we execute it again 2 minutes later and the malware was still there. And it's because that function execution environment lives for a bit to avoid the overhead of firing up a new cold environment every single invocation. So there is some persistence here. The processes running do seem to shut off and go away, but your malware could be re-invoked on every single execution without having to rewrite the file into the containerized environment. So the question again, how long do these warm environments stick around for if you're not actually invoking the function? This was a little bit of a moving target. So you got different numbers every time we tested it. On average, AWS Lambdas, 11-ish minutes is how long that thing lives for. Azure functions will stick around for about 6 minutes with your malware in there before it disappears. GCP functions, again, the most recycled, about every 3 minutes. Those went away. So that is the snapshot of credentials and persistence inside of the execution environment. Let's poke around with Azure here. This is actually pretty fun. So we'll do the same thing. We're going to establish a reverse shell into, this time, the Azure function. So we'll see this pop up our netcat listener here. And what we're going to do is we actually need to grab the JWT from that MSI endpoint. So We invoke our MSI endpoint with the secret. Now we've got the JSON web token scoped to storage.azure.com. And we'll just copy that out of the function over to the attacker's machine. And I've got all these requests preloaded up just with a $ bearer token in there, just to make it easy to just paste in the token and rock and roll. So you can see right now I'm asking what storage accounts do we have. You can see the audience scoped as it runs its way through the burp side. And we can see, yes, there is a storage account there. Let's look at the containers inside of it. So we've got an images container. And of course, I've got my pretty picture of our cougar friend inside of there. Inside of the container, now let's list the blob objects inside of the images container. Play the same game. Yes, there's an image. And then on the third request, we'll actually pull the image out of the bucket, or the blob. Sorry, I call them all buckets, even though I know Azure has different terminology. All right, so now we can see the raw image contents. And you can play the same game with the key vault. You just have to go back in and request a different token scope to the vault service instead. So that's how simple it is to use those tokens in Azure, as long as you know where they are. That was the hardest part, was just finding them. Coincidentally, there's not a lot of documentation on where that thing lives. So there was an obscure posting about the managed identity service that I found. And ultimately, I ended up in the Azure Functions web job GitHub repo. So thanks, Ken, for having all the folks make that public. And all I did was I went into the managed identity class inside of there and actually saw how they were grabbing their credentials from the functions environment. And that kind of tipped me off on where to go locate those things. So open source is awesome for that stuff, right? All right, let's switch gears. Let's go blue team a little bit. We'll try to figure out, did we leave a trail behind us as we did all this stuff? And there are auditing tools in all three clouds. You've got to turn them on in order to actually see what just happened. So CloudTrail is probably the most well-known AWS audit service. As long as you've got CloudTrail turned on and you're capturing data events from S3, you would see me taking those tokens and swiping that picture from the bucket from a rogue IP address that clearly is not an internal Amazon function IP. On the Azure side, this was a little bit of a headache. Azure Monitor, I would say, is probably the least mature out of the three of these, because you can't turn it on globally. CloudTrail and IAM audit logs, you go to that service and say, capture all the things, and you're done. In Azure, you have to go to every individual resource. So think your Azure storage account, you have to turn on diagnostics. Azure Key Vault, you have to go turn on diagnostics. And if you got 38 key vaults, you have to turn on 38 different key vault diagnostics in order to get the audit logs that you want detecting these exfiltration attacks. So infrastructure as code is really important here, right? Make sure you've got a module that automatically does that for you. Otherwise, you're going to miss the glorious information that you're seeing on the slide. So this is me querying Key Vault info, saying, all right, the resource provider is Microsoft.KeyVault. It's a little Custo query that you can use to query their diagnostic log tables. And we're looking for the resource name, which in this case, the Key Vault key I was pulling out was the Cougar database password. And you're looking at some interesting caller IP addresses here. So let me zoom in on this a little bit so it's easier to see. So this is really what you're looking for almost from an IR perspective. So 20.189, that's an Azure IP. So that's normal activity for a function running in their environment. However, then you can see me, the random IP, doing the same thing with the same username, the same managed identity ID. So suddenly you're freaking out, right? Because that shouldn't be possible. allows it to happen because it doesn't really have any restrictions on where it can be invoked from out of the box. You got to do something to make that happen. So let's look at some of these access controls. Where are we sitting here? We got about, what, 15 minutes left. Should be good to go on getting through the last blue team discussion side of things here. In order to gain access to any of this stuff, you've got to yank the function out of the, quote, managed VPC that they default into, the network that they're running in, and you have to bring it onto your side of the responsibility model. So in Lambda, you integrate it with the VPC service. In Azure, you have to upgrade to a premium function plan. So you've got to pay a little bit more money. What this actually does under the hood is it turns your function from an on-demand consumption based, where you only get charged for 10 milliseconds of execution time. It puts you in a full-time running function environment. So all of those persistence things I talked about, those are out the door, because now the function is just alive. It's basically like turning it into a full-time server. But when you do that, you get VNet integration. So you can take that function, put it in a VNet, and then you can start setting up egress filters and VPC flow logs, and a lot of the stuff we'll go through. On the GCP side, this is challenging to set up, but mostly it's just because I didn't understand how GCP wanted me to do it. GCP, like I said, is very project isolated oriented. So in order to set this up, you need to create a host project that has a shared VPC in it. You need to share that VPC with your function project, and then you need to have your function turn on the serverless VPC access feature and launch all of its traffic, ingress and egress, through the shared VPC. So it takes a little bit of work to get it set up, but you've got some really tight centralized controls there on watching what your functions are doing if you go through the headache of getting it set up. When you do that, where we're going to land here is your function's probably broken, because you've gone from a network that has an internet gateway and public IPs to a network that you're in charge of that doesn't have any of that stuff in it. So you've got to go through your progression of setting up a NAT gateway inside of the VPC for egress and responses. And then you've got to go in and turn on some of the other hardening techniques we'll talk about to lock down some of the resource traffic from an exfiltration perspective. So we did this for the Lambda function in this scenario. This is the serverless framework. So there's a serverless.yaml file that's in the repo that I pointed you to earlier. And if you flip an environment variable when you build it, it'll put you in a custom VPC in private subnets with the NAT gateway, and it'll set up a security group rule that allows you to set up some egress filters. Security groups is the resource in AWS you want. Network security group is how you would do it in the Azure VNet, and then GCPs are just called firewall rules. So they're actually very simple to work with and set up. And then you can start blocking the outbound C2 connection on port 1042. So we've kind of got that green path highlighted at this point. So we're forcing our egress traffic to go over port 443, for example. Here's the code that you'll see fly in here when you do that. So when we're even locking this down, instead of all zeros on the CIDR block, we've got maybe the trusted corporate network, maybe that's an upstream proxy that's going to capture and inspect and do all the next gen firewall things to our function traffic. Whatever it is that you need to set up, that's where your traffic has to route through. From a network forensics perspective, about the best you can do here is setting up flow logs. And in some cases, I don't know, and maybe somebody out there knows, I don't know if you can do traffic mirroring from a function network interface. I haven't seen it done. Maybe it's possible, but flow logs are kind of aggregate net flow data. They give you some indication of the source and destination ports and IP addresses that the function's talking to. In the Azure world, network security group flow logs, same thing in GCP. So you can turn all those on. It's very simple. Get the log data into the centralized logging service so we can query it and actually detect that C2 channel getting blocked on port 1042. So I'll show you what that looks like here in a minute. The query itself, now this is against a CloudWatch log group using CloudWatch log insights, but you could also use the Kusto query I showed you over in Azure to query their log source. And in GCP, it's a little bit different of a syntax, but the same drill. You can see in the output, I'll zoom in a little bit on this. We're now getting the traffic flow to port 1042, the demo that I showed you being registered in the function's flow logs, which is way more visibility than we started with. Now we know that C2 is happening. The next question is there a way to block the credentials that we stole from the function from actually being used outside the environment? Can you do that? And as it turns out, a number of services, not all of them, but a number of services, the common ones like Secrets Manager, the buckets, the storage services, the vaults, the key management service, they all support internal routes from the VPC without having to traverse over the internet. So in AWS, you're looking at VPC endpoints. In Azure Functions, you're looking at Azure private endpoints. And in GCP, it's a little bit different. You set your VPC up to route DNS. All Google APIs will go to the restricted Google APIs. So those are internal routes to the GCP APIs. And once you do that, you can turn on a control called VPC service controls, which sets a perimeter around one too many projects. So if you set that around the project that has the storage bucket and our secrets in there, the data inside of that project cannot leave the perimeter. And by default, VPC service controls keeps it all inside of the GCP virtual network. It can't leave. Unfortunately, that blocks you out as an administrator from even from the web console. You cannot browse to a storage bucket inside of that perimeter unless you poke a hole in it and say, here's some administrative IPs that are allowed to do this thing, whatever the action you're trying to do is. But all three of those will force your function to talk internally on the network to the APIs and block the outside world from stealing the images or the secrets, whatever it is that you're worried about being exfiltrated. So nice exfiltration controls there. The example on the slide, this is us setting up the endpoint for AWS. So we're standing it up for S3 and then applying a bucket policy. This is how you would do it on the AWS side per resource that ultimately says, look, this principal, which is the role the function is running under, cannot get images from this bucket unless it comes from the VPC that we expect it to be in. When I steal the keys and run them from my laptop, I'm going to get access denied because I'm not coming from a trusted location. So it's a way to lock that down from that perspective. And then you'll also, when I get that access denied externally, you're going to see CloudTrail pop up and say, weird, this user ID suddenly jumped over to this IP and I rejected the request. So you'll have that audit trail. Okay, so let's do the last demo. Then I'll give some shout outs to some folks that helped out and or motivated me to work on this a little bit, figure out how all this stuff works. Last setup, this is the AWS side. So same deal. We've got the Netcat listener running. Now with egress in place, so we're filtering all traffic on port 443. Notice it's dead. We're not getting our command and control on port 1042 because the egress security group rule is blocking that. So that's a win. That activity is also conveniently, because we've got it in our own VPC with flow logs on, we are seeing that reject in the flow log traffic at this point. So it's a nice little network forensics add-on is, yeah, we're actually monitoring what our functions are up to at this point, which is much appreciated by the InfoSec team. So I ran a logs query. Here's me grabbing the results back out. And this should show us the reject coming from wherever I happen to be in the world when I ran this demo. So there it is. There's the function IP. There's the external IP that I ran it from. Port 1042 is what I tried to get C2 on and rejected. We shut it down. So let's try again. Let's do what any good attacker would do, which is let's just assume that port 443 is allowed outbound, because it always is. We'll flip over to port 443 and get command and control and dump our creds that way. And of course it works. So now we're grepping the environment variables for AWS for the access and secret key and the session token. We need that too. So there's the 3 values that we need. So we'll quickly just set our 3 environment variables so we can authenticate to the AWS account as the function. And one more to go here. And let's try to dump that S3 object. So here we go, the big moment, the data exfiltration, access denied, which is what we expect because we've got the bucket policy in place, establishing that trusted perimeter for that particular user ID. So we can't get to it. Now I've got all the CloudTrail logs pumping into an Athena table, and we're going to search for requests from that function identity. So we'll see what shows up in the CloudTrail logs. Hopefully it shows our attacker trying to get in there and exfiltrate data. And then we've got some incident response scenarios, obviously, that we would probably kick off, hopefully. So filtering down to access denieds, and there we go. There's the S3 request to list objects from, you know, whatever IP address I was at when I ran this demo. So overall, that concludes the walkthrough of all of the various security controls that we discovered missing and or available across all 3 functions, platforms, and the big 3 clouds. Primary motivation here, Gal Bashan actually has an awesome write-up from a few years back called Lambda Internals. And when I read it, I thought to myself, that is so cool. AWS focused, that was part of the motivation for exploring how you could do the same sort of thing in GCP and Azure. Shout out to Brandon Evans, a buddy of mine who helped me get used to writing serverless framework deployment files and getting these functions set up. He's been an awesome contributor to the project. For those interested in more of the AppSec side of serverless security, there is a flavor of kind of an OWASP top 10 project out there for serverless. It was mostly contributed by PureSec and Pertigo, 2 big serverless security companies that do quite a bit of research in the area. So some other resources for following up, learning more, etc. With that, that ties off the walk through defending your serverless infrastructure. Thank you all for attending and hanging out. I'll pass it back to Seth and Ken for some conversation or whatever y'all have going on.
Awesome. Well, thank you, Eric. Firstly, thank you so much for your time. We obviously greatly appreciate it. I don't see any questions here so far, but yeah, it was definitely cool to see all of this in multiple cloud environments. Jeez, you can tell it's getting late. I couldn't remember the word cloud. So
it's because it's dark out.
Yeah. Well, and here it's snowing where I'm at. So, but yeah, no, but thank you so much. That was amazing. I'm still watching. I don't see any questions. So I think, yeah, we'll thank you for your time. And just so for everybody watching real quick, we are going to put out, obviously all these materials and presentations will be available after the stream, since that question had come up earlier. Seth, do we have anything else you want to mention?
No, not necessarily. We will post up Eric's information as well. So if you've got further questions on it, Eric at some point too, we'll probably want to have you back on the podcast to talk even more, because I think there's a lot to explore there. Like I do have some questions on how, like what the surface looks like, and you know what I mean, like how you got into it. But I don't think we can cover it all in a minute. So
sure. Yeah, lots to unpack. I mean, that's like
lots to unpack.
2 to 3 months of research crammed into a 45-minute session there.
Yeah.
So.
I was just going to ask how long all that research took.
Yeah, that was kind of like my my holiday exploration last Christmas, and it bled into like I was finishing the research in the hotel room before I walked into RSA, so that was kind of the time frame.
Nice, cool. Yeah, well, we'll keep the conversation going. Post it up so people can hit you up on Twitter or wherever else. And yeah. Also the Slack channel.
The Slack channel. Yeah, I'm in there. I'm kind of a lurker. I don't contribute much, but if you tag me in something, I'll find it eventually.
Sweet. Okay. All right. Well, thanks again for your time and your support, Eric. And
you bet. Have a good night, fellas.
Yeah.
Right.
Have a great night.
Awesome. So let's add Jen to the stream. Oh yeah, sorry, buttons moved while I was trying to hit add to stream. All right, so we've got Jen and Jenny up next to discuss security and privacy, but specifically, like, I think one thing that's going to be really interesting, well, there's going to be many things that are interesting, but one thing that for me was interesting, and I think if you're watching this, you've probably gone through sort of like third-party questionnaires, and you've probably had to answer questions trying to figure out like risk, like the amount of risk, had to go through like what should be our risk tolerance. I just think this is going to be a very interesting and very practical talk. So I'm super excited. And with that, let's welcome in Jenny and Jen. Hi.
Hello.
Thank you for joining and presenting. We greatly appreciate it. We can, if you have slides, if you share, I don't know which one of you is going to share, we can add it to the stream once it's shared.
Yes, I've got slides to... How is it best to share that?
Oh, so you can hit share screen, and then it should just be like an application window, I think.
Yep, I see. You know, I'm a technical person. I don't do tech.
That is not true. You're very technical. So,
yeah. All right, share screen. Sharing screen. Hopefully, it tells me which one. Yep, that's the one.
All right, let's see here. Got it.
All right.
And so with that, the rest of us will hand it over to you and remove ourselves from the stream. We are here. We are present if you need us. But otherwise, we're just in the green screen room, we'll say.
Awesome. Right. Thank you very much. So, all right. Well, hello, and welcome to Let 'em Eat Cake and Cookies. I am Jen Chermushnyuk. I am a security engineer at GitHub, embedded in the sales team. So some people talk about shifting security left. I actually shifted my job left. And Jenny?
Hi, I'm Jenny. I'm the privacy program manager at GitHub as well. And we are small but mighty, and we're trying to make it a great place for both employees and users in terms of privacy.
So we know what you're thinking, especially with some recent things in the news lately about the cake is a lie, specifically with what Ken was just saying about third-party questionnaires. So hopefully in the next 30 minutes or so, we'll be able to convince you otherwise.
But first, a disclaimer. Neither of the gens in this talk is a lawyer, and nothing in this talk should be considered illegal advice, requirements, or anything else for your work. This talk is for knowledge sharing and to give you a gluttonous sugar overdose to associate with alphabets of privacy, security, and compliance acronyms. Standard disclaimers apply. Snarky comments are our own or attributed loosely to others in the space, loosely. Also, where I or we share of things we've built on GitHub, they are open source and freely repeatable.
All right. So if you think that popping shells is really where it's at for enterprise security, we've got news for you. It's not. So what is it about? Why are we here? Starting with the what. It's security questionnaires. A questionnaire is security practices and controls that you give to vendors, and they then turn around and give you lies. That's what a friend of mine said, who's a CISO who sends these out. Personally, I think it's more an opportunity to be able to put your best foot forward and make a sale through showcasing your security and privacy programs and practices. Hopefully, a chance to build trust through transparent and non-BS answers. So very quickly, let's run through a few of the sort of more common types of security questionnaires. The first that we've got is the Google VSAC, created by Google. It's open source, happens to be hosted on GitHub, but it can be hosted in-house as well. It's basically an essay question that it starts with about your network and your systems. Kind of makes me feel like I'm back in school where I had a teacher who said, when in doubt, write more. Sometimes it's when in doubt, write enough to hang yourself. I don't know. Google's VSAC is a little bit sneaky, is it's tailored to the entity that's using it. So sometimes you get the bite-sized one-pager that's then followed up with 3 more courses. One thing that's kind of interesting that I've called my baker's tip for my folks that are filling these out is that you can actually download them as a JSON file so that next year you've got your answers saved from the previous year. It's a little bit like when you save the top layer of your wedding cake for eating on your first anniversary. So not to be confused with the Google VSAC, we've also got Vendor Security Alliance VSAC. This one is built by a conglomeration or alliance of fairly well-meaning big customers who get a deluge of these things. Some of the partners are Airbnb, Uber, Big Data, Palantir. One hesitation I have with this questionnaire is it's marketed heavily in conjunction with a pay-to-play company, where sure, it's one thing if you share publicly, but their terms and conditions, if you read their policies for privacy and sharing, they fully declare that they're going to outright use any control data that you share with them to market and make money off of. But anyways, it's not a bad questionnaire. It's another one that you'll see. Another one, this one is the SIG. It's the Standardized Information Gathering. It's a set of questionnaires that comes, I like to joke, in 3 flavors. It's really 2, but light, medium, and creme brulee. As in creme brulee, house scorching, burned down. It's just monstrously large. Either version, either the SIG or SIG Lite, which are the real 2, are heavy lift. These are things that traditionally it's the super risk adverse customers, the financial services industry, insurance, heavily regulated utilities are serving these up. The fun thing about these questionnaires is they trigger, when you open them as an Excel file, a macro warning. So if you enable, first rule of security, right? Disable macros. I know my security awareness training is working because when my engineers call me and ask me if I'm going to kill them for enabling macros, I guess the awareness is working. In case you wonder what selecting those macros does, we've got a nice little Giphy here that one yes turns one question into 15. I do still wait for the day that when I click enable macros that I'm going to get the pop-up that says I am the weakest link, goodbye. So that is that one. HECFAT, this is a really new questionnaire. I've seen it sort of a handful of times, and each time it's come in with 3 or 5 or 6 different folks asking for them. So I guess I can tell what the period of time is for university conventions. It's kind of the turducken of security questionnaires because the first 5 questions are, do you have a SOC report? Do you have a cake? Do you have a SIG-Lite? Please attach. And then proceeds to ask in another 500 questions, all of the same questions that those questionnaires have in them. So this is kind of my preference for the standard questionnaires. This is the Cloud Security Alliance Consensus Assessment Initiative Questionnaire, or CAKE, hence the name of the talk. Cloud Security Alliance's questionnaire is not particularly married to one specific regulatory scheme or security framework. It works really well, particularly for customers or for folks like us who are not tied to one particular like NIST or ISO, but because it maps to all of them. So it's kind of something for everybody. It's got 14 areas that cover policy, it covers governance, infrastructure, application security that I get to bug Ken for, and basic control responses. So this is really sort of the tool that we use the most. And it's the one that I particularly like serving up to customers because it's a good first way of opening. Getting away from the questionnaires and more into the why or what is driving these questionnaires. There's federal and community and worldwide rules, regulations, and laws. So first one that is definitely driving some of these questionnaires is FedRAMP, or the Federal Risk and Authorization Management Program. This is the program that the US government uses to authorize any and all cloud services for the government. It is now officially required for all federal agency cloud deployments to use services that have these categorizations. It's not a certification exactly, it's called an authorization to operate, so ATO. And they come in low, moderate, and high impact. There's also another fun little one that's called tailored, which is typically between low and moderate. And it's where they keep shifting the goalposts on you. You need to be past the low for low impact for data use, but you don't really need to be moderate. But once you get to a certain level, then they want you to keep going further. The important one, the thing coming out of FedRAMP specifically, is continuous monitoring. So that's a question that a lot of the questionnaires come up with. Next, HIPAA and high tech and high trust. HIPAA, Health Insurance Portability and Accountability Act. It's the 1P HIPAA, the other is the beast, that is 2P. HIPAA is a law that obviously requires healthcare companies and anyone else dealing with patient health records is subject to HIPAA. Companies who are subject to HIPAA have obligations to protect the patient health information downstream. So they'll often ask for their vendors to sign what are called BAA, Business Associate Agreements, making sure that you promise that you'll keep the same standards they do, even though you're not actually subject to HIPAA. High tech is the health information technology and economic clinical act. This is actually encouraging all of the healthcare companies to modernize and bring records into electronic form so that they're more easily accessible. That, of course, though, promotes the security piece that needs to be done, which then pushes out to high trust. High trust is an audit standard saying that you meet all of the HIPAA regulations and rules. Like FedRAMP, HIPAA and high-tech aren't questionnaires, but they're the reason for it. High trust, being the audit standard, is sort of where you'll see customers asking if you are. Main thing to know about HIPAA is there's some serious consequences with violation. Misuse or breach of PHI is bad news and can bring personal liability, though not a lawyer. I am thankful to have the clear direction from our company when I'm answering questionnaires to say very clearly, we will not sign the BAA. BAAs are bad news. HIPAA is kind of the one thing that can trigger to turn a chief security officer into a chief jailable officer. So not going there. Then for all of those of you who have thought, you know, security is kind of fun, but maybe we should bring accountants into it and see what they say. SOC 2 compliance, or SOC compliance, which is the American Institute of CPAs, yes, accountants, service organization controls. Most folks are familiar with these. There's a couple of different varieties. SOC 1 is for folks that have financial obligations to stakeholders, for SOX, S-O-X, Sarbanes-Oxley. And then SOC 2 has trust service criteria in 5 categories of security, availability, process integrity, confidentiality, and privacy. Because they're accountant-led, they're pretty expensive, talking $500 an hour sometimes for these. But like the FedRAMP authorization, if you have a SOC report that you can just hand to a customer, that is a huge sales win, and definitely a collateral piece that I may be guilty in saying that or tweeting out that I was never so happy as to have a pair of socks for Christmas. So last but not least, where SOC and FedRAMP are very sort of American focused, we have ISO, ISO 27000. ISO, which is the International Standards Organization, is a set, and specifically the 27000, which is what deals with information security management systems, is sort of a roadmap and best practice approach for helping organizations meet information security requirements by addressing people and processes as well as technology. So that is a very quick overview, and I will hand it off to Jenny for privacy, which is far more interesting.
I hope you think so too, and welcome to this whirlwind tour of various privacy regulation. So speaking of things that come out of outside of America, you probably heard of these 4 letters repeatedly over and over in your head, and you wish it would stop. What are we talking about? GDPR stands for the General Data Protection Regulation, and it's a very comprehensive regulation with the goal of standardizing laws and penalties across EU countries, but also across the world, because obviously EU data gets to other places. And elevate the notion that privacy is not only the right thing to do, but it's almost, or should be, an essential human right. So, but Europeans know, like we were saying, that they're not the only thing on Earth, and data needs to be shared to operate. So they come up with this framework called the Privacy Shield that allows the transferring of data outside of the European Union, as long as you follow the requirements that it specifies. And the framework is also pretty easy. It just takes self-attestation. Privacy Shield had a pretty good run for about 4.5 years until a privacy activist from Austria managed to get it invalidated in July of 2020, which is, you know, not even 6 months ago, while litigating with Facebook in Ireland. Actually, it's 2-0 in favor of Max Schrems versus data transfers to the United States. The first one he got invalidated was called Safe Harbor. Some of you might still remember it, which had a much longer run of 15 years. So RIP data transfers. Thank you, Max. So now instead of Privacy Shield, non-European countries rely on a thing called the Standard Contractual Clauses, or SCCs. And in case you were wondering, yes, it's pretty much a mandatory question we have to answer affirmatively to when we fill out a questionnaire. Another good thing, delicious thing that comes out of the European Union is the cookie regulation, and it's part of the e-privacy overall directive. And if you ever had a doubt, the Europeans mean business. You might have heard just last week, Google was fined 100 million euros, and Amazon was fined 35 million euros by the French Data Protection Agency for shady cookie practices on their French localized pages.
Ouch.
Very ouch. After focusing on Europe, we're gonna go slightly on a larger scale. And there are many countries in the world with their own privacy regulations. We won't cover all of them, but I will mention a few notable ones. More four-letter acronyms, yeah. LGPD, or the Law for General Protection of Data. It sounds much better in Portuguese. And it comes to us as fresh as of August 2020. So again, very recent, not even 6 months. Overall, LGPD has a very similar approach to GDPR in terms of what a data subject, also known as a person, is entitled to do or to get. The most significant difference in the LGPD versus GDPR is mostly notable in the allowed response times. And in Brazil, it's much shorter. It's only 15 days and not the 30 days that are allowed in the European Union. However, there's a pretty big difference in the overall approach to how data subjects can lodge a complaint. Under GDPR, the person is expected to reach out to the company first, and then the company's data protection officer will have to address their complaint. While in Brazil, it's very common for a citizen to go straight to court if they think they have a case. Next, please. Yep. And here too, we're going to talk a little bit about Russia. You might get a little confused with the other picture in the frame, but you should be in the mindset of what stays in Russia. Sorry, what happens in Russia stays in Russia. There you go, urban joke. Perhaps it's because there's a vast amount of free space in Siberia and cooling data centers comes very cheap there. Either way, the Russians passed a bill that proclaims that any data that was produced in Russia has to stay on Russian soil.
Trust but verify? No. Sorry.
Mother Russia does not trust. Last stop on our world tour is Canada with their PIPDA, that's how they call it, or the Personal Information Protection of Electronic Documents Act. That's a mouthful. Our close neighbors from up north passed this data protection bill all the way back in 2000, and it has been doing pretty well. However, 20 years into it, they've started work on revamping their data protection regulation, and to do that, they're generalizing a bill that originated in Quebec. Okay? Let's go back home, and turns out that all 50 states in the US, as well as Washington, D.C., Guam, Puerto Rico, and the Virgin Islands have regulation detailing requirements for electronic data breach notifications. On top of that, a few states have passed more specific bills covering physical data protection, as well as a few other tidbits, and we'll cover just a couple. First, we'll go to sunny California. You might have heard of CCPA or CPRA, more four-letter acronyms. Looks like California has a lot to offer, not just beach bums, and they do care about customer privacy as well. The highlight of this bill is that each resident of California may object to their data being sold to advertising companies. That's very short. There's a lot more that's covered in that bill. Fun fact, some companies apply that regardless of where you are at, or maybe it's because my final destination was in California. So I just want to say kudos Philippine Airlines on a beautiful check-in experience when flying back from Thailand last winter. I missed you so. Last but not least in our tour of the US is the Illinois Biometrics Act. If you're a resident of Illinois, any company must obtain your explicit consent before they can process your biometric data. That means fingerprints, palm prints, facial scans, etc., etc. Yes, you heard it right, Facebook. That means no auto tagging group photos.
No. Fun. Does that mean that you also have right to consent, like GDPR? Oof. So we've talked a lot about the what. How about some why? Why do we fill these out? For our health? We did discuss HIPAA and high trust, but mostly legal due diligence. We've got to know what we don't know. Whether it's mergers and acquisitions, where you may be acquiring somebody else's bad cyber hygiene, or if you've tried to get cyber insurance recently, you've got to prove that you have your vendors managed. Want to win government contracts? You've got to be able to show you don't use things in your systems like Huawei or Kaspersky that we've got executive orders coming out saying we can't use. But this is my favorite, and I made my boss spit coffee out of his nose when I said that sex has been usurped. It's actually security that sells these days. Anything that shortens the spin of the sales cycle, while we can't exactly lob the cake over the wall and be done, along with FedRAMP ATOs, SOC reports, business associated, not business associated agreements, if you can avoid them, but business impact assessments like privacy has. Anything that you can proactive and be pro-offering before your customer serves up a questionnaire is a good thing. Asking about security concerns up front, making sure that the salespeople have sort of a basic security and privacy vocabulary helps to keep the security heartburn and the deal killing to a minimum. It's kind of funny when security and privacy can actually be the department of yes, and here's how, rather than department of no. So who fills these out? Well, obviously Jenny and I do. The question tends to be, with typically RFIs historically, it's finance folks, right? Because they're the ones that have the information about where the company's registered, and how many people, and what the org chart looks like. Problem becomes security and privacy gets a little bit particular with context. So as you can see with this carrot, it's close, but not quite. When you ask a finance person like my husband about encryption, they're like, well, sure, I can use TLS to encrypt things, data at rest. Like, okay, sure. Context really matters. So having some sort of framework or something that gives the folks that are filling these things out context. Personally, as an SME and an old hat, can sometimes machine accounts is the right answer, and sometimes it's a very wrong answer. So I need to know what the context is 2 questions before, 2 questions after. Oftentimes I get people throwing one question at me. It's like, little context, please. So should security be filling these out? Do you really want your platform engineers, your application security team, threat hunters, or CERT filling these out? Wouldn't you prefer that they actually be doing their day job and like burning down tech debt and protecting you and us from whatever is out there? So it oftentimes falls to sales. So how do you get sales folks to deliver the right answers and real answers? And how do you scale it? Because they just keep coming more and more, no matter whose job it is to fill out these questionnaires. Sometimes it's a trickle, other times it's a complete deluge, which is certainly now, as we've seen with the Max Schrems 2 decision recently. The privacy questionnaires that we thought were coming with GDPR that sort of trickled in have just gone boom, and we are suddenly buried in them. So we've tried the tiered approach with tiers, T-I-E-R-S, rather than T-E-A-R-S. To general tier, for the tier 1, you've got general users, free and legacy accounts on standard terms of service. They get purely your prepared collateral. So if you've got a SOC, not so much, but if you've got the cake, let them eat cake. Tier 2 legacy accounts, they've got a little bit larger spend. They're on the corporate terms of service. Start with the cake, but we'll give them a little bit more icing. We can give them the NDA protected sales collateral, like the SOC reports, if you've got ISO certification. Tier 3, so really the folks that are paying you big bucks and want to know that all of their data is going to be safe and secure, and you're going to promise your firstborn, yes, we'll fill out your questionnaire, and we'll even allow you to have seconds. But it may take longer to be served as it takes more preparation. So again, we're talking about sort of those small tiers, about the tiers saving tiers. It's a nice idea, but it isn't always easy to say no. Particularly salespeople don't ever want to say no. Oh, come on, pretty please, just for me. Sometimes we really do, for sanity's sake and bandwidth of resources, need to draw a line. So thresholds or other things. We're not going to fill out a Google VSAC, or particularly the SIG, which is 1,000+ questions. Yes, 1,000. For a free optional add-on, particularly if you're not a paying customer. But this isn't our decision. But in this case, the head chef or VP of security, or sorry, of sales, is who makes the ultimate call, because it is a business call, not a security call in this case. But for scaling and reproduction and giving really good guardrails for sales folks who are not security engineers or privacy engineers, that you want to make sure that they've got some real answers. It's sort of creating a cookbook or a guide to be able to serve up responses. You get all of the subject matter experts, the lawyers, the privacy, the security folks at the table once. You get good, solid answers, and then you figure out how to serve them up over and over and over again until something changes. For us, we've actually got a little automation here, just like these cookies, with a Slack bot that you can actually type in with a little bit of coffee script and a whole bunch of frequently asked questions and answers in a markdown file. We've figured out a way to put answers into our whole team's hands and hopefully prevent some of the half-baked answers. And again, we will share this if anyone is interested. And it is 100% open source. Little Hubot that answers questions in Slack. You can type .secq and add a security term, and it will pull from our markdown file. This is a little bit of a eye chart, but I can do .rem, or for remember, and the cake, and it pulls up the link for where the cake can be served from. SECQ FedRAMP, and it gives me an answer of where I can find for FedRAMP. And Hubot at the very bottom here is reminding us that he, like we, know that software is awful. So we talked about how to handle them. How do we handle sales folks who just don't want to say no? We don't do that yet. Or if you're a small company and you have an onboarding list that's a Google spreadsheet. Focus on automating processes that you do have and customer data protection. Questionnaires should be a sales tool, but like many small SaaS, your change management is kind of lightweight. There's going to be holes. No one is expecting anything perfect. Certainly if I'm the one decorating the cake. But sharing is caring, and if we don't have something, it's a great opportunity for the sales folks to share that, you know, we're not quite there, but it's on the roadmap. So just a quick way to say, to give our sales folks who really, really don't want to say no, an honest way of saying no, but it's coming. So hopefully with all of those tools, we've convinced you that the cake is not a lie. So, time for questions if we have any.
And thank you, by the way, again. I'm watching another channel for questions and pass along any of those questions and add, let's see, some of the folks back onto the feed. So a few things, just real quick while we wait for any questions to roll in. Like I said, thank you both again. Jennifer and Jenny, you mentioned it. We're coworkers at GitHub. Jennifer and I have talked for a long time. Super great resource, very knowledgeable. And there were a couple things that were super interesting. One was the way that you easily broke down sort of like what you can have. You can have cake and cookies. You can do this, you can do that. That's very memorable and an easy way to break it down. I also thought it was super interesting, given like having gone to Brazil and knowing sort of the culture, that they were more stringent. That was interesting to me because I would have thought they'd be more laid back on this. So it being like 15 versus 30 days was pretty interesting. Didn't expect that.
Maybe it's the money. I mean, there's some pretty good fines. I don't know about the Brazilian one specifically, but there's some pretty hefty fines to be lobbied with some of those laws.
Yeah,
I couldn't believe that. Oh, sorry. Go ahead.
You could say that the process is actually less stringent, right? Because if you're expected to file an official complaint with the company and then wait for the DPO to respond, and then maybe it goes to court, that in Brazil, like, oh, I think I have a case. I'm going to try it.
Yeah.
One thing you mentioned too with Facebook was you had mentioned auto tagging was not possible, and that was just limited to anyone that was posting photos from Illinois? Is that how that works? Or like, it's interesting, I guess, just the implication in general that you would have to potentially modify your tech per region. So
yeah.
Yeah.
So that's definitely a challenge that I've noticed in when I switched to the privacy field. In my past, I was a developer. And it all seems like everyone heard about the big ones like GDPR, but then you don't think about all the smaller ones, and especially, an area we didn't cover at all is actually what happens to employee data and how many specific employment laws you need to follow, whether it's per country or per state. And in the questionnaires that I've been seeing recently, I've definitely seen an increase in companies asking more privacy-related questions, but also questions both about their customers' data, but also their employees' data. So for example, what sort of employee data will you retain as a service if we use your services, like your product?
Right. I mean, yeah, no, that definitely makes sense. It's so interesting that. Sorry, go ahead.
And I didn't answer the original question, but so the specific case that was with Facebook is that they use some database of photos to train their AI to identify faces, and then turns out that some of those photos were of Illinois residents, and then Facebook never collected consent about those residents. So, and the Illinois people filed a lawsuit and they won. And essentially, it's not like, one way to think about it is that you need to modify your practices. Like, you can't just apply in bulk whatever you're trying to do. The other way to think about it is that you need to know what data you're using and where it's coming from, right? So like, don't just go and take a random picture off the internet. Know the ancestry of what you're doing.
Yeah, be responsible in your practices is essentially. So I think what you're saying in the collection of data. Yeah, no, that was I love this stuff, especially it's interesting just to hear that security is actually a selling point now. I think I speak for probably most of the people on this call, probably a lot of the people listening and the folks that will listen. That's not usually how we feel it's looked at. So it's surprising to hear, and in a positive way, surprising to hear that. So.
Yeah.
Yeah, I absolutely love that you two addressing all of the surveys that come out of client-driven compliance requests and requirements, and who are you going to get to fill all that stuff out? Are you going to take time away from your security engineers or the people that are doing red teaming to pause and fill all that information out? And then also how you scale that. That was both of those components were great to hear about.
Yeah, we're still working. I think we actually have headcount to help us scale coming. So if you know anybody that really enjoys answering these things and chatting with a Hubot. Yeah.
Yes, awesome. Well, so we're going to have some of the other folks join back on this call. Again, we really appreciate you taking your time. I know this was no small effort. I know that I like really bugged you to do this talk. So thank you so much. I really do appreciate it. Seriously.
Thank you.
It was my pleasure.
Yeah.
Thank you. Bye. Awesome.
All right.
So yeah, Abdullah, I'll hand it over to you if you'd like to. I know there were a few points. I'm a little tired at this point, so I think there were a few things that you said we should mention, or at least one.
So, I mean, thank you so much to InfoSec and On for doing the graphics for the conference, the whole Midwinter's Nights Con. All the really cool graphics were done by her. They're great. Thank you so much for all of that.
I'll post her Twitter her Twitter account now.
And then for tomorrow, we're gonna go ahead and get started at 1600. So we'll see everybody at that time for the first talk. Ken and Seth, did you guys want to mention anything about how and when the videos get posted?
Yes, they will be posted. So this main stream will be live from here on out, right? So the full stream I don't know if we're going to get to cutting it tonight or before we post everything tomorrow. It'll probably be post-con that we'll chop them up into the different talks, and we'll post them separately on a playlist on the Absolute AppSec YouTube channel for Midwinter Nights Conference. So we'll just watch this space or watch our Twitter account, and we'll post as soon as those are available. Probably give a short summary on each one on Twitter when we do. Yeah. Yep. Yeah. Otherwise, thanks everybody for joining us tonight. It's been a lot of good info in there. I'm going to have to go back and rewatch a couple of those. There's stuff that I missed that I want to make sure I understand. So appreciate everyone that's helped organize and helps put it all together. So,
and don't forget Toys for Tots or EFF. We gave links in the very beginning of this video. So if you feel compelled to donate because you feel compelled, then do that. So yeah.
Super.
All right.
Okay. Well, thanks everybody. We'll see you tomorrow. Remember, there's a different link for tomorrow as well. It's on the main page for the conference, or it's in your email if you've registered. So we'll see everybody then.
Thank you, everyone.
Thanks, guys.
Night.